The universe is full of mysteries, some we think we understand, others that leave even the brightest minds baffled. From the everyday puzzles of nature to the deepest questions about reality itself, science is constantly uncovering new layers of complexity. But for every answer we find, more questions emerge. In this video, we're going on a journey through 100 of the greatest unsolved mysteries in science, ranked from the easiest to grasp to the most mind-bending and obscure. We'll start with familiar topics, questions about space, life, and the human mind, before diving into the truly bizarre, where the boundaries of physics, consciousness, and existence itself are called into question. Some of these mysteries may be solved in our lifetime, while others might remain unanswered forever. Either way, they push the limits of human understanding and remind us just how much there is left to discover. So, get ready to explore the unknown as we begin at level 1 and work our way to level 100, the deepest, strangest mysteries of science. Level 1. When we look up at the night sky, we see stars, planets, and galaxies. But surprisingly, all of this visible matter makes up only a tiny fraction of the universe, about 5%. The rest? Scientists believe it's made up of something we can't see, something mysterious called dark matter. Dark matter doesn't emit light, absorb it, or interact with electromagnetic forces, which makes it completely invisible. Yet, we know it must be there because of its gravitational effects on galaxies. Without dark matter, galaxies would spin apart, their stars moving too fast to be held together by the visible matter alone. So, what is it? Some theories suggest it could be made of unknown particles that don't interact with normal matter, while others propose more radical ideas, like modifications to the laws of gravity. Despite decades of research and massive underground detectors searching for evidence, no one has ever directly observed dark matter. It remains one of the biggest unsolved mysteries in physics, one that might redefine our understanding of the universe. Level 2. If dark matter is strange, dark energy is even stranger. While dark matter seems to hold galaxies together, dark energy is doing the opposite. It's tearing the universe apart. In the late 1990s, astronomers made a shocking discovery. The universe isn't just expanding, it's accelerating. This means galaxies are moving away from each other faster and faster over time. But what's causing this? The leading theory is dark energy, an unknown force that makes up about 68% of the entire universe. Scientists have no idea what dark energy actually is. Some think it could be a fundamental property of space itself, a force woven into the fabric of the universe. Others believe it might be a sign that our understanding of gravity is incomplete. Whatever it is, dark energy is shaping the future of the cosmos. If its effects continue unchecked, it could eventually rip galaxies, stars, and even atoms apart in a doomsday scenario known as the Big Rip. For now, dark energy remains an enigma, one of the greatest mysteries in all of physics. Level 3. We spend about 1/3 of our lives asleep, yet scientists still don't fully understand why. Sleep is essential. Going too long without it can lead to hallucinations, memory loss, and even death. But what exactly happens when we sleep, and why do we need it in the first place? At first, sleep might seem like a huge evolutionary disadvantage. While sleeping, animals are vulnerable to predators, unable to find food, and not reproducing. Yet, every complex organism, from humans to tiny insects, has some form of sleep or rest cycle. This suggests it must be critical for survival. One theory is that sleep helps the brain process information and store memories, almost like a biological reset button. Another suggests that it plays a key role in healing and cellular repair, allowing the body to recover from daily stress. More recent research even suggests that sleep helps clear out toxic waste in the brain, reducing the risk of neurological diseases like Alzheimer's. Yet, despite all these theories, no one knows exactly why sleep evolved or what its true purpose is. It remains one of the biggest unsolved questions in biology, one we experience every single night. Level 4. Right now, you're aware that you're watching this video. You can think, reflect, and experience emotions. But what exactly is consciousness, and where does it come from? At first glance, it might seem like an obvious question. Consciousness is simply being awake and aware. But when scientists try to define it, things become far more complicated. Consciousness isn't just about being able to respond to stimuli. It's about having a subjective experience, the internal feeling of being you. And this is where the mystery lies. Neuroscientists have mapped out different regions of the brain responsible for things like memory, emotions, and decision-making, but none of this fully explains how all these neural processes come together to create the experience of consciousness itself. It's one thing to understand that electrical signals are firing in the brain, but why does that produce thoughts, sensations, and self-awareness? This is known as the hard problem of consciousness. How physical processes in the brain give rise to the feeling of being alive and aware. Some scientists believe that consciousness emerges from complex information processing in the brain. The idea is that once a system, like the human brain, becomes sufficiently advanced, self-awareness naturally arises. Others take a more radical approach, suggesting that consciousness isn't just something that happens in brains, but is instead a fundamental part of the universe itself, much like space and time. This theory, known as panpsychism, proposes that consciousness exists at a basic level in all matter, even in things we consider inanimate. Then there's the question of whether humans are the only beings that experience consciousness. We assume that animals like dogs, dolphins, and even birds have some level of awareness, but what about artificial intelligence? Could a machine ever become truly self-aware? If so, what would that mean for the way we define intelligence and life itself? Despite years of research, no one has been able to fully explain what consciousness is or how it comes into existence. It remains one of the greatest scientific and philosophical mysteries, one that challenges our understanding of reality itself. Scientists may one day uncover the answers, but for now, the question remains. What exactly is the thing that makes you, you? Level 5. Have you ever walked into a place you've never been before, only to feel like you've already experienced that exact moment? This eerie sensation is called déjà vu, which means already seen in French. But what causes it? Déjà vu happens suddenly, lasts only a few seconds, and is often impossible to predict. Scientists have studied the phenomenon for years, yet no one fully understands why it happens. Some theories suggest that it's caused by a small glitch in the brain's memory system, where new experiences accidentally get processed, as if they were past memories. Others believe it may be linked to the way the brain processes information too quickly, creating the illusion that we've already seen or done something before. There's also a theory that déjà vu could be connected to dreams. Maybe we're experiencing something similar to a forgotten dream, making it feel strangely familiar. Some more speculative ideas even suggest that déjà vu could hint at parallel universes, moments where we briefly sync with an alternate version of reality. While there's no evidence for this, it remains a popular idea in science fiction. For now, déjà vu remains an unexplained quirk of the human mind, one that almost everyone experiences, but no one fully understands. Level 6. Every night we enter a world of shifting realities, bizarre events, and impossible experiences, our dreams. No matter who you are, where you live, or what language you speak, you dream. But why? What purpose do these nightly journeys serve? Scientists have studied dreaming for decades, yet there is still no single, definitive explanation for why we dream. One of the most widely accepted theories is that dreaming plays a role in memory consolidation. While we sleep, the brain sorts through the experiences of the day, deciding what to keep and what to discard. Some researchers believe dreams are a byproduct of this process, as our subconscious mind replays and reorganizes information, sometimes in ways that don't make logical sense. This might explain why we sometimes dream about events that happen during the day, only with strange, unexpected twists. Another theory suggests that dreams help us process emotions. Throughout history, people have reported having vivid dreams during times of stress, anxiety, or major life changes. Some researchers propose that dreaming allows us to rehearse difficult situations in a safe, imaginary space. This could be an evolutionary adaptation, helping our ancestors prepare for dangers or challenges before they happened in real life. Even today, we sometimes wake up from an intense dream feeling, as if we've gained insight into a problem we've been facing. Then there's the idea that dreams may be completely random, According to the activation synthesis theory, dreaming is just the result of neurons firing chaotically while we sleep. The brain, always trying to find patterns and meaning, takes these random signals and weaves them into a story, often one that makes little sense upon waking. This could explain why dreams often feel disjointed, jumping from one place to another with little connection between events. But not all dreams are out of our control. Some people experience lucid dreams, moments when they become aware that they are dreaming and can even influence what happens next. Lucid dreaming has been studied in scientific labs, with researchers confirming that people can learn to control their dream world to some extent. But how this works and why some people can do it more easily than others remains unknown. There are even more speculative ideas about dreams. Some believe that dreams could offer a glimpse into alternate realities, while others suggest they might be a kind of hidden language of the subconscious, revealing deeper truths about our desires and fears. While these ideas remain unproven, they highlight just how mysterious dreams truly are. Despite all the research, no one fully understands why we dream. Are dreams simply the result of random brain activity? A tool for problem solving? A way to process emotions? Or are they something even stranger, something we have yet to comprehend? For now, the mystery of dreams remains unsolved, hidden within the deepest corners of the sleeping mind. Level 7. From the moment we're born, our bodies begin a slow and steady countdown toward aging. Our skin wrinkles, our muscles weaken, and eventually, our cells stop functioning the way they once did. But why do we age at all? What is it about our biology that makes growing old inevitable? At a cellular level, aging is linked to damage and deterioration over time. One major factor is the shortening of telomeres, protective caps on the ends of our DNA that wear down every time a cell divides. Eventually, when telomeres become too short, cells stop replicating properly, leading to tissue damage and aging-related diseases. Another theory suggests that aging is caused by a buildup of genetic mutations and cellular waste, which interferes with normal functions. Some scientists even believe that aging is a side effect of our body's efforts to fight off cancer, as cells stop dividing to prevent uncontrolled growth. But here's the real mystery. Why did evolution allow aging to happen? If living organisms are meant to survive and pass on their genes, why didn't nature find a way to make us live forever? Some researchers believe that aging helps eliminate weaker individuals, making room for younger, stronger generations. Others suggest that aging wasn't directly designed by evolution at all. It's simply an unavoidable consequence of biology. If we could fully understand why we age, could we stop or even reverse the process? Scientists are actively researching ways to slow down aging, and some believe that humans could drastically extend their lifespan in the future. But for now, aging remains a deeply unsolved mystery, one that affects every single one of us. Level 8. Every person on Earth has a unique set of fingerprints, a pattern of ridges and loops that stay the same for life. We use them for identification. But why do humans and some animals even have them in the first place? One common theory is that fingerprints help us grip objects better, preventing our fingers from slipping. But some studies suggest that this might not be true. Experiments have shown that smooth skin can sometimes create better friction than ridged skin. Another idea is that fingerprints improve our sense of touch, allowing us to feel fine textures and detect small differences in surfaces. The ridges may help amplify vibrations, giving our brains more information about what we're touching. Then there's an evolutionary perspective. Could fingerprints help with survival? Some scientists believe they may have developed to help early humans and primates climb trees or handle rough surfaces more efficiently. But here's the biggest mystery. Why is every fingerprint unique? Even identical twins who share nearly the same DNA have different fingerprint patterns. This suggests that fingerprints are shaped by a mix of genetics and random developmental factors, but we still don't fully understand how or why they form the way they do. Fingerprints are a small part of our bodies, but they hold a big mystery, one that science is still trying to solve. Level 9. Life is everywhere on Earth. From the deepest trenches of the ocean to the driest deserts and the highest mountains, our planet is teeming with living organisms. But at one point, billions of years ago, Earth was just a barren rock. No plants, no animals, not even bacteria. So how did life begin? What was the very first spark that transformed simple molecules into living, evolving creatures? One of the leading theories is abiogenesis, which suggests that life arose from non-living chemical reactions. In the early Earth's oceans, there were no living things, only a mixture of simple molecules floating in water. But conditions on the young planet were vastly different from today. Volcanic activity, lightning, intense UV radiation, and other energy sources could have triggered chemical reactions that created complex organic compounds, including amino acids and proteins, key building blocks of life. Over millions of years, these molecules might have assembled into self-replicating structures, leading to the formation of the first primitive cells. A closely related idea is the RNA world hypothesis. Unlike DNA, which stores genetic information but requires other molecules to function, RNA can do both. It can store information like DNA and also catalyze chemical reactions like proteins. Some scientists believe that before complex life developed, the first forms of life were RNA-based, capable of copying themselves and eventually leading to more advanced biological systems. This idea is supported by experiments that show how RNA molecules can form spontaneously under certain conditions. But not everyone is convinced that life originated purely from Earth's own chemical processes. Some researchers suggest that life, or at least its fundamental building blocks, may have come from space. This theory, known as panspermia, proposes that comets, asteroids, or interstellar dust could have carried organic molecules, or even primitive microbial life, to Earth from another location in the universe. Meteorites containing amino acids, the essential ingredients for proteins, have been found on Earth, supporting the idea that these fundamental molecules could have formed elsewhere and been delivered to our planet. If true, this would mean that life on Earth might have an extraterrestrial origin, and it raises an even bigger question. Did life first emerge somewhere else in the cosmos? Another fascinating possibility is that life began in environments very different from what we typically imagine. Instead of forming in shallow pools of water or on ocean shores, some scientists believe that the first life might have started near hydrothermal vents at the bottom of the ocean. These deep-sea vents release heat and minerals, creating a rich environment where complex chemical reactions could take place. Even today, extreme organisms known as extremophiles thrive in these harsh conditions, suggesting that life might have originated in a place we once considered too hostile to support it. Despite decades of research, no one has been able to recreate the exact process that led to life. Scientists have conducted experiments showing that amino acids, nucleotides, and other organic molecules can form under simulated early Earth conditions. But taking the next step, creating a fully functional, self-replicating system, is something we have yet to achieve. Without direct evidence, the true origin of life remains unknown. If we could uncover how life began, it would be one of the most important discoveries in human history. It could tell us not just about our own origins, but also about the possibility of life beyond Earth. If life started naturally from simple chemistry, then it may have happened elsewhere in the universe, perhaps on Mars, Europa, or even planets in distant star systems. But if the conditions that led to life were truly rare, then Earth might be the only inhabited world in an otherwise lifeless cosmos. Until we find conclusive evidence, either by creating life in a lab or discovering it elsewhere in the universe, the question of how life began remains one of the greatest mysteries in science. It's a mystery that touches on the very essence of our existence, reminding us how much we still have to learn about the origins of life and our place in the universe. Level 10. Gravity is one of the most familiar forces in the universe. It keeps us grounded to Earth, controls the orbits of planets, and holds entire galaxies together. But despite being one of the 4 fundamental forces of nature, we still don't fully understand what gravity actually is. Isaac Newton first described gravity as a force that pulls objects toward each other. The same force that makes an apple fall to the ground also keeps the moon orbiting Earth. But then Einstein's theory of general relativity changed everything. He proposed that gravity isn't really a force at all, but rather a warping of space and time. Massive objects like planets and stars bend the fabric of space-time, and this curvature tells other objects how to move. But here's where things get mysterious. While Einstein's theory perfectly explains gravity on a large scale, it doesn't work at the quantum level. In the microscopic world of atoms and particles, quantum mechanics takes over, and gravity doesn't fit neatly into the equations. This is why physicists have been searching for a quantum theory of gravity, something that could unite the laws of the very large with the laws of the very small. Even stranger, we still don't know what actually causes gravity. The other fundamental forces have particles that carry them, like photons for electromagnetism. But gravity's hypothetical particle, the graviton, has never been found. Could gravity be an emergent property of the universe? Could it be connected to hidden dimensions? Or is our understanding of physics fundamentally incomplete? Until we solve these questions, gravity remains one of the most persistent and puzzling mysteries in science. Level 11. The universe runs on a set of fundamental physical constants, fixed numbers that define how everything works. These include the speed of light, the gravitational constant, the charge of an electron, and Planck's constant, among others. But here's the mystery. Why do these constants have the precise values they do? If any of these numbers were even slightly different, the universe as we know it couldn't exist. If the gravitational constant were just a little stronger, stars would burn out too quickly, making life impossible. If the charge of an electron were slightly different, atoms wouldn't form properly, and chemistry wouldn't work. If the cosmological constant, which influences the expansion of the universe, were just a tiny bit larger or smaller, the universe would either collapse in on itself or expand too fast for galaxies to form. This fine-tuning has led some scientists to question why these constants have their particular values. One possible explanation is the anthropic principle, the idea that the constants must be what they are, because if they weren't, we wouldn't be here to observe them. Another possibility is the multiverse theory, which suggests that our universe is just one of many, each with different constants, and we just happen to live in one where life is possible. Others believe that there could be a deeper, unknown law of physics that determines these values, but we haven't discovered it yet. Are these numbers purely coincidental, or do they hint at a hidden structure to reality? Until we find an answer, the precise values of the universe's fundamental constants remain one of the greatest unsolved mysteries in physics. Level 12. The universe is expanding. But where is it going? Will it continue stretching into infinity, or is there an endpoint, a final fate waiting for everything we know? Scientists have spent decades trying to answer this question, but the truth is, we still don't fully understand what will happen to the cosmos in the distant future. One of the most widely accepted ideas is the Big Freeze, also known as the heat death of the universe. Right now, the universe is expanding, and thanks to dark energy, that expansion is accelerating. If this continues indefinitely, then over billions, trillions, and even quadrillions of years, galaxies will drift farther apart. Stars will burn through their fuel and die, and new stars will stop forming. Black holes, the last remaining structures, will slowly evaporate due to Hawking radiation, eventually leaving behind a vast, empty, and frozen void where nothing can happen, an endless dark silence stretching into eternity. But there's another possibility, one that suggests the universe won't expand forever. Some scientists believe that dark energy might weaken over time or even reverse its effects, allowing gravity to take over. If that happens, the universe could begin to slow its expansion, then eventually start shrinking in what's called the Big Crunch. In this scenario, galaxies would collide, space itself would contract, and in the final moments, all matter and energy would be pulled into an infinitely dense point, similar to the singularity that began the Big Bang. Some theories suggest that after this, a new Big Bang could occur, leading to a never-ending cycle of universes expanding and collapsing, one after another, in what's known as the Big Bounce. Then there's the most dramatic scenario, the Big Rip. This theory suggests that dark energy isn't just causing expansion, it's actually accelerating at an increasing rate. If this continues unchecked, there could come a time when the fabric of space itself stretches too fast, reaching a breaking point. First, galaxies would be torn apart, then solar systems, then planets, and eventually even atoms themselves. At the final moment, space-time itself would be ripped apart at a fundamental level, destroying everything in a cosmic catastrophe that would mark the absolute end of the universe. Each of these scenarios depends on forces we don't fully understand. The future of the universe is tied to the true nature of dark energy, a force that makes up nearly 70% of everything, but remains a complete mystery. If dark energy is constant, the universe may freeze to death. If it changes over time, we might be heading for collapse. If it accelerates uncontrollably, everything will be torn apart. For now, we can only observe, theorize, and try to uncover more clues. The ultimate fate of the universe remains one of the biggest unanswered questions in physics, one that may take millions of years, or perhaps an entirely new way of thinking, to fully understand. Level 13. The universe is vast, seemingly endless. But what lies beyond what we can see? When we look up at the night sky, we're only witnessing a tiny fraction of the cosmos, just the part that light has had time to reach us from since the beginning of the universe. This region is called the Observable Universe, stretching about 93 billion light-years across. But is there more beyond it? What exists outside our cosmic horizon? One possibility is that the universe is infinite, continuing forever in all directions. If that's the case, then space doesn't have an edge. It just keeps going, filled with galaxies, stars, and planets we will never be able to see. If the laws of physics are the same everywhere, then there could be endless versions of our own galaxy, solar system, and even alternate versions of you, existing in different parts of this infinite expanse. Another idea is that the universe is finite but unbounded, meaning that if you traveled far enough, you would eventually end up back where you started, kind of like walking around the surface of a sphere. In this scenario, the universe may have a curved shape, meaning that space bends back onto itself in higher dimensions, something we don't yet have the tools to detect. But what if the universe is just one part of something even bigger? Some theories suggest that our universe might be one of many, existing within a larger multiverse. This could mean that beyond what we can observe, there are other universes, each with different physical laws, dimensions, or even completely different forms of matter and energy. Some of these universes might be similar to ours, while others could be unimaginably different, some too chaotic for life, others with entirely new kinds of physics. There's also the possibility that beyond the observable universe, the physics we know may break down entirely. The constants that define our reality, like the speed of light, the strength of gravity, or the structure of atoms, might not hold true in regions of space we can never reach. Some theories even suggest that other pocket universes may be bubbling into existence all the time, each with its own set of rules, completely separate from ours. But how could we ever know? Since light has a speed limit, there are parts of the universe we will never see, no matter how long we wait. The cosmic horizon, the farthest distance light has traveled since the Big Bang, is constantly moving, and as the universe expands, some galaxies are being pushed beyond our reach forever. This means that, unless we find some breakthrough in physics, like faster-than-light travel, or a way to detect signals from beyond our universe, we may never be able to answer this question. For now, the mystery remains unsolved. What exists beyond the observable universe? More galaxies? Other universes? A completely different reality? We don't know, but whatever lies out there, it challenges everything we think we understand about existence itself. Level 14. The idea of multiple universes has fascinated scientists and philosophers alike for decades. Could our universe be just one of many? Could there be an infinite number of parallel realities, each with its own version of history, physics, and even alternate versions of ourselves? The concept of the multiverse is one of the most mind-bending ideas in modern science. But is there any real evidence for it? One of the strongest arguments for a multiverse comes from cosmic inflation, the idea that right after the Big Bang, the universe expanded at an incredible rate. Some theories suggest that this inflation didn't happen evenly everywhere. Instead, different regions of space could have inflated at different rates, creating separate bubble universes with their own physical laws. In this scenario, our universe is just one tiny bubble in a vast cosmic ocean of other universes, each possibly following different rules of physics, with some being familiar and others completely alien. Then there's quantum mechanics, which adds another layer to the mystery. The many worlds interpretation of quantum physics suggests that every time a decision is made, whether at the atomic level or in everyday life, the universe splits into multiple realities, each playing out a different possibility. According to this idea, there could be an infinite number of versions of you, each living in a slightly different timeline where different choices were made. In one universe, you may have chosen a different career, and in another, you might not even exist. String theory, one of the most ambitious theories in physics, also hints at a multiverse. This theory proposes that reality is made up of tiny vibrating strings of energy, and that there may be extra dimensions beyond the three of space and one of time that we experience. Some versions of string theory suggest that these extra dimensions could give rise to entire separate universes, each with its own unique laws of physics. But if other universes exist, can we ever prove it? The biggest problem with the multiverse hypothesis is that it's extremely difficult, if not impossible, to test scientifically. If another universe exists, it's likely separated from ours in a way that prevents direct observation. However, some scientists think that traces of the multiverse might be detectable in the cosmic microwave background, the leftover radiation from the Big Bang. If another universe once collided with ours in the distant past, it could have left imprints in this ancient light. There are also wild ideas that suggest certain quantum experiments might one day allow us to glimpse evidence of parallel worlds. Some even propose that black holes could be gateways to other universes, though this remains purely theoretical. So, do we live in a multiverse? Right now, we don't know. The idea is still speculative, but if it's true, it could mean that our reality is just one of infinite possibilities, and that what we call the universe is just a tiny piece of something much, much larger. Until we find a way to prove or disprove the existence of other universes, the multiverse remains one of the greatest and most mind-bending mysteries in science. Level 15. The universe is made mostly of matter, but according to physics, it shouldn't be. At the moment of the Big Bang, equal amounts of matter and antimatter should have been created. Since antimatter is the mirror opposite of matter, when the two meet, they annihilate each other. Everything should have canceled out, leaving behind nothing. And yet, here we are, in a universe made almost entirely of matter. This strange imbalance is called baryon asymmetry, and scientists have no idea why it happened. One possible explanation is that, for some unknown reason, the laws of physics favored matter over antimatter in the early universe. Experiments with subatomic particles have shown tiny differences in how matter and antimatter behave, but not nearly enough to explain why all of existence wasn't wiped out instantly. Some theories suggest that, in the first moments of the Big Bang, asymmetries in physics allowed just enough matter to survive, while the rest annihilated with antimatter. Others propose that antimatter could exist somewhere else in the universe, forming entire antimatter galaxies hidden from us. Until we find a clear answer, the question remains: why does anything exist at all? The mystery of matter's survival is one of the most fundamental unsolved problems in physics, and solving it could rewrite our understanding of the entire universe. Level 16. The universe is filled with some of the most extreme objects imaginable, but few are as mysterious as magnetars, the most powerful magnetic objects known to exist. These ultra-dense remnants of dead stars generate magnetic fields that are a quadrillion times stronger than Earth's, and yet, we still don't fully understand how they form or why they behave the way they do. Magnetars are a rare type of neutron star, created when a massive star explodes in a supernova. Unlike typical neutron stars, which are already incredibly dense, packing more than a sun's worth of mass into a sphere the size of a city, magnetars have an added layer of strangeness, an unbelievably intense magnetic field. If a magnetar were as close as the moon, its magnetic field would be strong enough to wipe the data from every credit card on Earth. These objects occasionally release giant bursts of energy, producing some of the brightest flashes ever detected in space. The reason for these sudden outbursts is still unknown, but they may be caused by shifts in the magnetar's crust, essentially starquakes that release massive amounts of radiation. Despite their extreme nature, only around 30 magnetars have been discovered so far, and no one knows exactly why they form in some supernova, but not others. Understanding them could not only unlock new physics about magnetism and neutron stars, but also help explain some of the strangest signals we detect from space, including fast radio bursts, mysterious high-energy flashes that might be linked to magnetars. For now, these objects remain one of the universe's biggest enigmas, powerful, unpredictable, and barely understood. Level 17. Earth's magnetic field is one of the most important forces protecting life on our planet. It shields us from harmful solar radiation, helps animals navigate, and even makes compasses work. But there's a mystery scientists still don't fully understand. Why do Earth's magnetic poles sometimes flip? Over the past 20 million years, Earth's magnetic field has reversed roughly every 200,000 to 300,000 years. That means the North and South poles literally swap places. The last full reversal happened about 780,000 years ago, meaning we might be overdue for another one. But what causes these flips, and when will the next one happen? Scientists believe the Earth's magnetic field is generated by the movement of molten iron in the outer core, creating a giant geodynamo. But for reasons we don't yet understand, this flow sometimes becomes unstable, causing the magnetic field to weaken and eventually flip. Right now, Earth's magnetic field is already weakening, and some researchers think we could be heading for another pole reversal in the next few thousand years. If this happens, it won't be an instant flip. It could take hundreds or even thousands of years to fully complete. But what would it mean for us? Some scientists worry that a weakening magnetic field during a reversal could expose Earth to more solar radiation, affecting satellites, electrical grids, and even increasing cancer risks. Others believe the effects would be minimal, as life on Earth has already survived hundreds of these reversals. Despite years of research, we still don't know exactly why these reversals happen, how to predict them, or what their full consequences might be. The only thing we know for sure is that Earth's magnetic poles are constantly shifting, and one day, they'll flip again. Level 18. Ball lightning is one of the strangest and most elusive natural phenomena ever recorded. Witnesses describe it as glowing orbs of light, usually the size of a grapefruit, appearing suddenly during thunderstorms. These mysterious spheres float, hover, and sometimes even pass through walls before vanishing in an instant, sometimes with a loud explosion. Despite centuries of reports, scientists still have no definitive explanation for what ball lightning actually is. Unlike regular lightning, which is well understood, ball lightning seems to defy the laws of physics. Some reports describe it lasting for several seconds, far longer than a normal electrical discharge. Others claim it moves against the wind, changes direction, or even appears indoors with no clear source. In rare cases, people have reported ball lightning passing through airplane cabins, adding to the mystery. Many theories have been proposed, but none have been proven. Some scientists think ball lightning is caused by microwave radiation, trapped inside a sphere of plasma, while others believe it could be burning nanoparticles of metal released by lightning strikes. There's even speculation that it could be a quantum effect, involving strange interactions between electromagnetic fields. Because ball lightning is so rare and unpredictable, studying it in a controlled environment is nearly impossible. Some researchers have attempted to recreate it in labs with limited success. For now, it remains an unexplained mystery, one of nature's strangest and most elusive light shows. Level 19. The sun is the ultimate source of energy for life on Earth, but there's something strange about it that defies common sense. Normally, you'd expect that the closer you get to a heat source, the hotter it gets. But when it comes to the sun, the opposite is true. Its outermost layer, the corona, is hundreds of times hotter than its surface, and scientists still don't know why. The sun's visible surface, called the photosphere, burns at around 5,500 degrees Celsius. But the corona, the glowing plasma that extends millions of kilometers into space, blazes at a staggering 1 to 2 million degrees Celsius. This shouldn't be possible under normal physics because heat is supposed to flow from hot to cold, not the other way around. One of the leading theories to explain this mystery is magnetic reconnection. The idea that the sun's constantly shifting magnetic field releases bursts of energy that heat up the corona. Another theory suggests that waves of energy, called Alf-Venn waves, might transfer heat from the sun's interior to the corona in a way we don't yet fully understand. Despite decades of research, this coronal heating problem remains unsolved. NASA's Parker Solar Probe is currently flying closer to the sun than any spacecraft in history, gathering data that might finally reveal the answer. Until then, the fact that the sun's outer atmosphere is mysteriously hotter than its surface remains one of the biggest open questions in astrophysics. Level 20. Across the world, thousands of people report hearing a mysterious low-frequency humming sound, a deep droning noise that seems to have no identifiable source. Known simply as the hum, this strange phenomenon has been heard in various locations, from small towns to major cities. Yet scientists still don't fully understand what's causing it. The hum is often described as a persistent, low rumble, similar to a distant engine or a deep bass vibration. Strangely, not everyone can hear it. Only about 2% to 4% of the population seems to be affected. And those who do hear it often report symptoms like headaches, dizziness, insomnia, and even nausea. The noise has been documented in places like Taos, New Mexico, Bristol, England, and Windsor, Canada, with some cases lasting for years. Many theories have been proposed to explain the hum. Some scientists believe it could be caused by low-frequency sound waves from industrial activity, such as gas pipelines, high-voltage power lines, or military communication systems. Others suggest it might be related to seismic activity, or even shifts in Earth's magnetic field. Some researchers have even explored the idea that the hum is not an external sound at all, but rather a form of spontaneous otoacoustic emission, where the human ear produces its own low-frequency noise. More speculative theories suggest that the hum could be linked to secret government projects, electromagnetic interference, or even an unknown geological phenomenon. Despite numerous investigations, no single explanation fits all cases, and in many locations, the hum remains a mystery. For those who hear it, the hum is more than just an unexplained noise. It can be a constant and disturbing presence, disrupting sleep and daily life. Until scientists can pinpoint its source, the hum remains one of the strangest and most frustrating auditory mysteries on Earth. Level 21. Time is something we all experience, but what exactly is it? We measure it with clocks, we see it pass as things age and change, and we assume it flows in one direction, from past to future. But scientists still don't fully understand the true nature of time, and some theories suggest that it might not even exist in the way we think. In everyday life, time seems like a simple, continuous flow. But in physics, time is much stranger. Einstein's theory of relativity showed that time is not absolute. It can stretch, slow down, or speed up, depending on how fast you're moving or how close you are to a massive object. This means time is relative, and for someone traveling near the speed of light, a few hours could pass while years fly by for someone else. Even more puzzling is that the fundamental laws of physics don't seem to require time to move in one direction. Equations describing motion, gravity, and quantum mechanics all work just as well forward as they do backward. So, why do we experience time moving only from past to future? Scientists call this the arrow of time, and one of the leading explanations comes from thermodynamics, entropy. The second law of thermodynamics states that in any closed system, disorder, entropy, always increases. This one-way increase in entropy might be the reason why we experience time in one direction, but no one knows why the universe started with such low entropy in the first place. Then there's the even bigger mystery. Is time real, or is it just an illusion? Some theories in physics, like loop quantum gravity, suggest that time might be an emergent property rather than a fundamental part of reality. Others propose that all moments in time exist simultaneously, meaning that past, present, and future are all equally real. But our brains just perceive them in a sequence. If these ideas are correct, then time as we experience it might not be a fundamental part of the universe at all. It could be a human perception, a byproduct of consciousness, or something even stranger that we haven't yet discovered. Until we unravel its true nature, the mystery of time remains one of the deepest questions in science. Level 22. In deep space, astronomers have detected mysterious, ultra-powerful bursts of radio waves that seem to appear randomly and last only milliseconds. These are known as fast radio bursts, and despite years of research, no one knows exactly what's causing them. Fast radio bursts were first discovered in 2007 when astronomers analyzing old telescope data found a single, extremely bright flash of radio waves that lasted just a fraction of a second. Since then, thousands more have been detected, some coming from deep within our galaxy, while others originate billions of light years away. The energy in just one of these bursts can be greater than what our sun emits in an entire year. At first, scientists thought fast radio bursts might be one-time cosmic explosions, but then things got even weirder. Some fast radio bursts repeat, coming from the same location over and over. This suggests they aren't just random events, but rather some kind of unknown astronomical object producing them under specific conditions. So, what could be causing them? Some theories suggest they come from highly magnetized neutron stars, magnetars, which could be releasing bursts of energy due to intense magnetic activity. Others think they might be linked to black holes, colliding stars, or even completely unknown types of celestial objects. And then there's the more speculative idea. Could fast radio bursts be signals from an advanced alien civilization? Some researchers have considered the possibility that they might be extraterrestrial beacons or even signs of intergalactic spacecraft propulsion systems. While there's no solid evidence for this, the fact that fast radio bursts are so powerful, precise, and still unexplained keeps this theory alive. Until we uncover their true nature, fast radio bursts remain one of the greatest space mysteries. Flashes of energy coming from the depths of the cosmos, arriving without warning and leaving us with more questions than answers. Level 23. Imagine losing a limb, yet still feeling it as if it were there, experiencing sensations like itching, pressure, or even intense pain in a body part that no longer exists. This bizarre and often distressing phenomenon is known as phantom pain, and despite decades of research, scientists still don't fully understand why it happens. Phantom pain occurs in over 80% of amputees, and it can range from mild discomfort to unbearable agony. Some people feel burning, stabbing, or even movement in their missing limb, as if their fingers are curling or their toes are being crushed. What makes this even stranger is that it's not limited to limbs. People who have lost breasts, eyes, or even internal organs have reported similar phantom sensations. One of the leading theories is that the brain doesn't realize the limb is gone. In the brain's sensory map, every body part has a dedicated area in the somatosensory cortex, and when a limb is removed, its corresponding brain region doesn't just shut off. It may start receiving signals from nearby areas. For example, some amputees report feeling their missing hand when their face is touched, suggesting that the brain is rewiring itself in unexpected ways. Another possible explanation is that phantom pain arises from disruptions in the nervous system. When a limb is amputated, the severed nerves may continue sending signals, creating the illusion that the missing body part is still present. Some researchers believe these nerves might misfire, sending pain signals even though there is no actual limb to experience injury. Amazingly, treatments for phantom pain involve tricking the brain into seeing the missing limb again. One of the most effective techniques is the mirror box therapy, where an amputee places their intact limb inside a mirror box, creating the illusion that their missing limb is still there. By moving their real limb and seeing its reflection, the brain may recalibrate and reduce the phantom pain. Despite these insights, phantom pain remains a deep mystery. Why do some people experience it for years, while others never feel it at all? Can we one day fully rewire the brain to eliminate it? Until we unravel the full workings of the nervous system, phantom pain remains a haunting reminder that the mind and body are deeply connected in ways we still don't fully understand. Level 24. The moon has been a constant companion to Earth for billions of years, controlling the tides, stabilizing the planet's rotation, and lighting up the night sky. But one mystery still puzzles scientists. How did the moon form? For decades, researchers have debated several theories about the moon's origin. One of the oldest ideas was that the moon formed elsewhere in the solar system and was later captured by Earth's gravity. However, this theory doesn't explain why the moon's composition is so similar to Earth's crust. Another idea suggested that Earth and the moon formed together, side by side, from the same cloud of dust and gas. But if that were true, we'd expect their compositions to be identical, which they aren't. The leading theory today is called the giant impact hypothesis. According to this idea, around 4.5 billion years ago, a Mars-sized planet named Theia crashed into the early Earth. This colossal collision would have vaporized huge amounts of rock, sending debris into space. Over time, this material clumped together, forming the moon. This theory explains why the moon is made mostly of Earth-like material, while still having some unique differences. However, there are still problems with this theory. Computer models suggest that most of the moon should be made of Theia's material, but studies of lunar rocks show that the moon is almost entirely made of Earth's crust, raising questions about how the impact really happened. Some scientists think that Theia's collision may have completely mixed its material with Earth's, while others believe there may have been multiple impacts instead of just one. To solve this mystery, scientists continue to study moon rocks from the Apollo missions, as well as data from robotic landers and orbiters. Future lunar missions might even uncover new clues hidden beneath the surface. Until then, the true story of how our closest celestial neighbor was born remains one of the greatest unanswered questions in planetary science. Level 25. At the quantum level, reality doesn't behave the way we expect. Particles can exist in multiple states at once, change their behavior when observed, and even seem to affect each other instantly across vast distances. But one of the biggest mysteries in quantum mechanics is something called the measurement problem. Why does a quantum particle choose a specific state when we observe it? In quantum physics, particles like electrons and photons don't have definite positions or states until they are measured. Instead, they exist in a superposition, meaning they can be in multiple places or states at the same time. This is best illustrated by the famous double-slit experiment. When electrons are fired at a barrier with two slits, they behave like waves, passing through both slits at once and interfering with themselves. But the moment we try to measure which slit the electron goes through, it suddenly behaves like a solid particle, as if it knows it's being observed. Why does this happen? No one knows. The collapse of the quantum wave function, the process by which a particle's multiple possibilities reduce to just one reality, remains unexplained. Some theories suggest that observation itself, or the act of measuring, somehow forces quantum particles to decide on a single state. This raises deep philosophical and scientific questions about whether consciousness plays a role in shaping reality. Others propose more exotic explanations, such as the many worlds interpretation, which suggests that instead of collapsing into one state, every possible outcome happens in a parallel universe. In this view, measuring a particle doesn't force it to choose a state. Instead, the universe splits, with different versions of reality playing out simultaneously. Then there's the idea that we are missing something fundamental about how reality works. Some physicists believe that hidden variables, factors we haven't yet discovered, might determine quantum behavior in ways we don't yet understand. The measurement problem is one of the deepest mysteries in physics, and until we find an answer, we are left with an unsettling question. Does reality exist in a definite state when no one is looking? Level 26. When we look around, space seems empty, just vast stretches of nothingness between planets, stars, and galaxies. But is space truly nothing, or is it something more? The true nature of space itself remains one of the biggest mysteries in physics. In classical physics, space was thought to be a simple, passive backdrop where objects exist and events happen. But Einstein's theory of general relativity changed that view completely. According to relativity, space isn't just emptiness. It's a flexible, dynamic fabric that can be warped and bent by massive objects like planets and stars. This warping of space is what creates gravity, meaning that space itself is deeply connected to the forces that shape our universe. But things get even stranger at the quantum level. Quantum mechanics suggests that even in the most perfect vacuum, space is never truly empty. Instead, it is constantly filled with quantum fluctuations, where tiny particles pop in and out of existence in a process called vacuum energy. This bizarre feature of quantum physics is why some scientists believe that space itself may have an underlying structure, possibly linked to something even more fundamental, like a quantum foam at the smallest scales. Even more mysterious is the idea that space might not just be something that objects move through, but a substance with its own hidden properties. Some theories suggest that space could be made of tiny, discrete building blocks, much like how matter is made of atoms. If true, this could explain some of the biggest problems in physics, like how to unite quantum mechanics with gravity. And then there's dark energy, the unknown force driving the expansion of space. If space is truly nothing, why is it growing? Some scientists believe that dark energy is an intrinsic property of space itself, meaning that empty space actually has energy of its own. But we don't know why or how. So, what is space really? Is it a smooth fabric, an invisible energy field, or something else entirely? Until we uncover the answers, the nature of space remains one of the greatest unsolved mysteries in science. Level 27. Deep in the ocean, thousands of feet below the surface, researchers have detected a mysterious sound that has puzzled scientists for decades. Known as the bloop, this ultra-low frequency noise was recorded in 1997 by underwater microphones operated by the U.S. National Oceanic and Atmospheric Administration. The strange part? The sound was so loud that it was picked up by multiple sensors over 3,000 miles apart, suggesting it came from an unimaginably powerful source. At first, some scientists speculated that the bloop might have been caused by a massive unknown sea creature, far larger than anything currently known to exist. This idea fueled theories that it could be linked to deep-sea monsters, such as a real-life version of the Kraken, or even something entirely new, hidden in the unexplored depths of the ocean. However, later studies suggested that the bloop was most likely caused by ice quakes, the cracking and shifting of massive icebergs in the ocean. While this explanation makes sense, it hasn't completely satisfied all researchers. Some argue that the sound's unique frequency and rapid rise in pitch don't fully match known ice-related noises. Adding to the mystery, the deep ocean is filled with other unexplained sounds, such as the upsweep, a repeating pattern of underwater noises detected since the 1990s, and the Julius signal, another unexplained low-frequency sound picked up in 1999. Could these sounds be natural phenomena, or do they point to something lurking in the ocean that we have yet to discover? With more than 80% of Earth's oceans still unexplored, it's possible that the bloop is just one clue to a much bigger mystery. Until we fully understand what's hiding in the deep, the possibility of unknown sea creatures, geological phenomena, or even undiscovered scientific processes remains open. Level 28. Migration is one of the most incredible behaviors in the animal kingdom. Every year, millions of birds, fish, and mammals travel thousands of miles, often returning to the exact same locations with astonishing accuracy. But how do they know where to go? How do animals navigate across entire continents and oceans without maps, compasses, or GPS? Scientists have discovered that many migrating species use the sun, stars, and landmarks to guide their journeys. Birds like Arctic terns, which migrate over 44,000 miles each year, rely on the position of the sun during the day and the stars at night. Sea turtles, which hatch on beaches and later return to the exact same spot decades later, appear to navigate using Earth's magnetic field, an ability called magnetoreception. But how does this work? Researchers have found that some animals have special magnetite crystals in their cells, which might allow them to sense magnetic fields. Others may use a quantum biological process in their eyes that lets them see Earth's magnetic field as a faint glow or pattern. However, the exact mechanism remains unknown, and experiments haven't fully explained how animals can navigate with such precision over long distances. Even more mysterious is how some species, like salmon, are able to memorize the exact chemical signature of their birthplace and follow it back after spending years in the ocean. Monarch butterflies, which migrate thousands of miles to the same forests in Mexico, somehow pass their navigational ability down through generations, despite the fact that no single butterfly ever completes the entire journey. Do animals possess a built-in biological GPS? Is there an unknown sense we haven't yet discovered? Despite decades of research, animal migration remains one of nature's most mind-boggling mysteries. One that shows just how much we still have to learn about the hidden abilities of life on Earth. Level 29. If you place two identical containers of water in the freezer, one hot and one cold, you'd expect the cold one to freeze first, but sometimes the hot water actually freezes faster. This bizarre phenomenon is known as the Mpemba effect, and despite being observed for centuries, scientists still don't fully understand why it happens. The effect was named after Erasto Mpemba, a Tanzanian student who noticed in the 1960s that hot ice cream mix froze faster than cold mix. Since then, experiments have confirmed that under certain conditions, warm water can indeed freeze more quickly than cooler water. But why? There are several possible explanations, but none fully settle the debate. One theory is that evaporation plays a role. Hot water evaporates more, reducing its mass and allowing it to freeze faster. Another idea is that hot water changes its molecular structure, affecting the way it cools. Some researchers suggest that hot water develops convection currents, which improve heat loss compared to still cold water. More recently, some studies have proposed that differences in the way hydrogen bonds behave in hot and cold water might be responsible. Water molecules interact in complex ways at different temperatures, and it's possible that heating changes the structure of the liquid in a way that speeds up freezing. Yet, no single theory has been able to explain the Mpemba effect consistently in all situations. Some experiments show it happening, while others fail to reproduce the results. Even though the effect has been documented for centuries, including by Aristotle in ancient Greece, it remains a puzzling mystery in physics. Why does hot water sometimes freeze faster than cold? The answer is still unknown, proving that even something as simple as freezing water can lead to one of science's strangest unsolved mysteries. Level 30. Every moment of your life, your brain is storing experiences, learning new information, and recalling memories. But how does the brain actually store and retrieve memories? Despite decades of research, scientists still don't fully understand the exact process behind one of the most fundamental aspects of human cognition. We know that memories are stored in networks of neurons, with different parts of the brain playing different roles. The hippocampus is essential for forming new memories, while the cerebral cortex helps store long-term information. When we remember something, our brain doesn't just replay a stored video. It reconstructs the memory from bits of information scattered across different regions. But how these neural patterns actually encode specific details, emotions, and sensory experiences is still a mystery. One of the biggest unanswered questions is why some memories last a lifetime, while others fade quickly. Some scientists believe that stronger neural connections, reinforced by repetition or emotional significance, make memories more durable. But why do some memories vanish completely, while others can be recalled in perfect detail decades later? Even stranger, memories are not always accurate. Studies have shown that the brain can alter, distort, or even fabricate memories, making them unreliable. This raises questions about how memories are stored in the first place. Are they permanent records, or do they change every time we recall them? There's also the question of where exactly memories are stored. Some researchers suspect that memory isn't just located in individual neurons, but might be distributed across the brain in a way we don't yet understand. Some even propose that quantum effects could play a role in consciousness and memory, though this idea remains speculative. Until we uncover the full mechanism behind how the brain encodes, retrieves, and modifies memories, the mystery remains unsolved. How does the brain turn electrical impulses into vivid recollections? How much of what we remember is real? And could we one day unlock the ability to fully control, edit, or even erase memories at will? For now, the secrets of memory remain hidden within the complex machinery of the human mind. Level 31. At the heart of a black hole lies a place where our understanding of physics completely breaks down: the singularity. According to Einstein's general relativity, when a massive star collapses under its own gravity, it forms a black hole, an object so dense that not even light can escape. But what happens at the very center of a black hole remains one of the biggest mysteries in physics. A singularity is thought to be a point of infinite density and zero volume, where space and time themselves cease to function in any meaningful way. The laws of physics that govern everything else in the universe, gravity, quantum mechanics, even the passage of time, no longer apply in their usual form. This means that inside a black hole, our current equations simply stop working, leaving us with more questions than answers. One major problem is that general relativity and quantum mechanics don't agree on what happens inside a singularity. Relativity predicts an infinitely dense point, but quantum physics suggests that nature doesn't allow infinities like this to exist. Some scientists believe that singularities might not actually exist at all, and that some unknown force prevents matter from collapsing infinitely. One possibility is that singularities could be replaced by a yet undiscovered state of matter, sometimes called a Planck star, a hypothetical ultra-dense object where quantum effects create a repulsive force strong enough to stop complete collapse. Others suggest that black holes might be gateways to other regions of space-time, or even tunnels to new universes. And then there's the question of what happens to information that falls into a black hole. According to quantum mechanics, information cannot be destroyed, but if a singularity exists, it would seem to erase everything that falls into it. This is known as the black hole information paradox, and solving it could help bridge the gap between quantum mechanics and gravity. Until we develop a working theory of quantum gravity, the true nature of a singularity remains unknown. Is it a point of infinite density, a hidden doorway to another universe, or something even stranger? For now, the singularity remains a place where physics itself seems to break apart, an unsolved mystery at the edge of reality. Level 32. For decades, scientists and astronomers have been searching for an answer to one of the most profound questions of all. Are we alone in the universe? The sheer size of the cosmos suggests that life should be common. There are trillions of planets orbiting stars across billions of galaxies, many of which could have conditions suitable for life. And yet, despite years of searching, we have no confirmed evidence of extraterrestrial civilizations. This is known as the Fermi paradox. First proposed by physicist Enrico Fermi, the paradox asks, if intelligent life is common, why haven't we seen any signs of it? If alien civilizations have been around for millions or even billions of years, they should have had plenty of time to develop advanced technology, colonize other planets, or, at the very least, send signals into space that we could detect. But so far, our radio telescopes have picked up nothing but silence. There are several possible explanations for this eerie lack of contact. One idea is that intelligent civilizations are extremely rare, and we might be among the first. Life could be common, but the development of advanced spacefaring civilizations might be exceptionally difficult. Another possibility is that alien civilizations exist but are deliberately avoiding us, either because they don't want to interfere or because they see us as too primitive to communicate with. Then there's the disturbing idea known as the Great Filter, the possibility that something prevents civilizations from advancing too far. This could mean that most intelligent species self-destruct before reaching a stage where they can explore the galaxy, whether through war, resource depletion, or technological disasters. If this is true, it raises an unsettling question. Has humanity already passed the Great Filter? Or is it still ahead of us? Another possibility is that we're simply looking in the wrong way. Advanced civilizations might communicate in ways we don't yet understand, using neutrinos, quantum signals, or even dimensions beyond our perception. Or maybe they exist in a form so different from us that we wouldn't recognize them even if we saw them. Until we find undeniable proof of alien life, whether microbial, intelligent, or something beyond our imagination, the Fermi paradox remains one of the greatest mysteries in science. Are we truly alone, or is the universe teeming with life that we simply haven't found yet? The answer could change everything we know about our place in the cosmos. Level 33. The universe follows strict physical laws, but one of those laws presents a troubling mystery: the second law of thermodynamics. It states that entropy, or disorder, always increases over time in a closed system. This means that, eventually, the universe should reach a state where all energy is evenly distributed, and no useful work can be done. This is known as the heat death of the universe, a scenario in which everything, stars, planets, and even black holes, decays into a cold, lifeless void. But why does the universe move toward disorder in the first place? If the laws of physics allow time to move forward and backward equally, why do we always see entropy increasing rather than decreasing? This question is directly tied to the arrow of time, the reason we experience time moving in one direction rather than another. While physics suggests time should be symmetrical, our experience of time always flows from past to future. One possible explanation is that the universe started in an extremely low entropy state at the Big Bang, a condition so improbable that some physicists believe it needs a deeper explanation. Why was the universe in such an ordered state to begin with? If entropy always increases, then wouldn't it make more sense for the universe to have started in a highly disordered state instead? Some scientists propose that entropy might be linked to the expansion of the universe. If the universe eventually stops expanding and begins contracting, entropy could reverse, making time run backward. But this remains purely theoretical. Others speculate that new universes could be born from the remains of our current universe, with entropy resetting under conditions we don't yet understand. The fate of the universe depends on how entropy behaves in the long run. Will everything eventually freeze in perfect equilibrium? Or could new physics emerge that changes the way entropy works? Until we can answer these questions, the mystery of why the universe moves toward disorder remains one of the deepest unsolved puzzles in physics. Level 34. Most people are right-handed, but a small percentage of the population, about 10%, is left-handed. This might seem like a simple biological trait, but the truth is, scientists still don't fully understand why handedness exists, or why most humans favor their right hand over their left. Handedness is linked to the brain's structure and function. The left side of the brain controls the right side of the body, and vice versa. Since the left hemisphere is usually dominant in language and fine motor skills, most people naturally develop right-handedness. But this doesn't explain why some people are left-handed, or why right-handed dominance is so strong across all human populations. One theory suggests that handedness is genetic, but no single left-handed gene has been identified. In fact, identical twins, who share the same DNA, don't always have the same dominant hand, suggesting that genetics alone doesn't determine handedness. Some researchers believe that environmental factors in the womb, such as hormone levels or fetal positioning, may also influence whether a person becomes left-handed. Even more mysterious is the question of why left-handedness persists at all. In history, left-handers were often forced to switch, yet they continue to make up a consistent minority in every human society. Some studies suggest that left-handed individuals may have certain advantages in sports, creativity, or problem-solving, which might explain why left-handedness has never disappeared, despite being less common. Interestingly, other animals also show preferences for one side over the other, but humans have a far stronger right-hand dominance than most species. Why is that? Did evolution favor right-handedness for some unknown reason? Or is handedness just a random variation with no deeper explanation? Despite decades of research, the true cause of left-handedness remains unknown. Is it purely biological, influenced by culture, or shaped by something even deeper in our brains? Until we unlock the full mystery, the reason why most of us favor one hand over the other remains an unsolved puzzle in human evolution. At level 35, one of the strangest and most mind-bending mysteries in physics is quantum entanglement, a phenomenon so bizarre that even Einstein famously called it spooky action at a distance. It suggests that two particles can be instantly connected, no matter how far apart they are, even across the entire universe. But how is this possible? Does it mean that information can travel faster than light? And what does it reveal about the true nature of reality? To understand entanglement, we first need to look at the weird rules of quantum mechanics. Unlike ordinary objects, which exist in definite states, quantum particles like electrons and photons don't have a single fixed property until they are measured. Instead, they exist in a state called superposition, meaning they can be in multiple possible states at once. Now, here's where things get truly strange. When two particles interact, they can become entangled, meaning their quantum states are now linked together. No matter how far apart these particles move, whether inches or billions of light years, a change in one instantly affects the other. This means that if we measure the spin, polarization, or some other property of one particle, we instantly know the state of its entangled twin, even if it's on the opposite side of the galaxy. This seems to defy the laws of physics, especially Einstein's theory of relativity, which states that nothing can travel faster than light. Yet somehow, the information between entangled particles appears to be exchanged instantaneously, faster than light could ever carry a signal between them. This paradox led Einstein and other physicists to believe that quantum mechanics must be incomplete, and that some hidden variables must exist to explain what's happening. For decades, scientists debated whether quantum entanglement was real or just a mathematical trick. But in the 20th century, a physicist named John Bell came up with a way to test it, known as Bell's theorem. His work showed that if quantum mechanics was correct, then entangled particles truly would behave in an instantly correlated way, without any hidden variables. When experiments were performed, the results confirmed quantum mechanics. Entanglement is real, and there were no hidden variables explaining it. So, what does this mean for our understanding of reality? Some physicists believe that entanglement suggests that space and time are not what they seem, that at a deep, fundamental level, everything in the universe might be connected. Others suggest that entangled particles aren't actually sending information between them, but rather they exist as a single system, with no real separation between them, even across vast distances. Then there's the even more mysterious idea that entanglement could be the key to future technology. Scientists are already exploring ways to use it for quantum computing, where entangled particles could perform calculations far beyond the capabilities of today's computers. There's also the possibility of quantum teleportation, where information can be transferred instantly between locations. Some researchers even speculate that entanglement could one day allow for instantaneous communication across space, which would revolutionize how we explore the universe, if we can find a way to harness it. But for now, quantum entanglement remains one of the deepest and strangest mysteries in physics. Why does it happen? What does it say about the nature of the universe? And could it mean that everything, matter, energy, even consciousness, is fundamentally connected in ways we don't yet understand? Until we find a complete explanation, entanglement challenges everything we thought we knew about reality. Level 36. Nuclear fusion is the holy grail of energy production, an almost limitless clean power source that could solve the world's energy crisis forever. It's the same process that powers the sun and stars, where atoms are fused together under extreme heat and pressure, releasing massive amounts of energy. But despite decades of research, we still can't make it work efficiently on Earth. Why is fusion so difficult to achieve? Unlike nuclear fission, which splits atoms apart, the process used in nuclear reactors, fusion requires forcing atomic nuclei together, overcoming their natural repulsion. This demands temperatures of millions of degrees, hotter than the core of the sun. The challenge isn't just generating these extreme conditions, it's sustaining them long enough to produce more energy than the process consumes. Scientists have built experimental fusion reactors like tokamaks and stellarators, which use powerful magnetic fields to contain superheated plasma. The ITER reactor in France is currently the world's biggest fusion project, aiming to generate self-sustaining fusion reactions, but it's still years away from commercial energy production. Some breakthroughs, like laser-driven fusion, have shown promise, but none have yet reached the ultimate goal of producing more energy than they consume, a state called ignition. So, what's holding us back? The biggest obstacle is plasma stability. Fusion fuel is incredibly unstable, and the extreme conditions needed to maintain the reaction make it difficult to control. Small disturbances can cause the plasma to cool down or escape, shutting the process down before it can generate useful energy. Some researchers believe that new approaches, like quantum fusion, advanced superconductors, or even small-scale fusion reactors, might lead to breakthroughs in the coming decades. If we ever crack the fusion problem, it could provide virtually unlimited energy, with no greenhouse gases and minimal radioactive waste. For now, nuclear fusion remains a scientific dream, one that could change the world if we can finally unlock its secrets. The question is, how much longer will we have to wait? Level 37. Every second, Earth is bombarded by cosmic rays, high-energy particles traveling through space at nearly the speed of light. These particles come from all directions, and while some originate from the sun, others arrive from deep space, carrying more energy than anything we can create on Earth. But where exactly do they come from? And what is accelerating them to such extreme speeds? Cosmic rays are mostly protons and atomic nuclei, but what makes them mysterious is that some have millions of times more energy than the particles produced in our most powerful particle accelerators, like the Large Hadron Collider. These ultra-high energy cosmic rays are so powerful that they shouldn't exist under our current understanding of physics. Scientists believe they must be coming from the most extreme objects in the universe, such as supernova explosions, active galactic nuclei, or even collisions between black holes and neutron stars. One of the biggest puzzles is how these particles can travel across the universe without losing energy. According to physics, cosmic rays should interact with background radiation, gradually slowing down over time. Yet, some reach Earth with energy levels that defy expectations, suggesting they might have come from sources beyond our observable universe, or that unknown physics is at play. There's also the question of why cosmic rays seem to arrive randomly, rather than from specific sources. If they were coming from a single type of event, we'd expect to see patterns in their arrival. Instead, they appear to be scattered, as if something, perhaps magnetic fields stretched across galaxies, is bending their paths in ways we don't yet understand. Even more intriguing is the possibility that cosmic rays could be evidence of new physics, perhaps linked to dark matter, extra dimensions, or unknown particles. Some scientists have even proposed that the highest energy cosmic rays might be coming from decaying cosmic strings, remnants of the early universe, or even intelligent alien civilizations using unknown technologies. Despite years of study, cosmic rays remain one of the biggest unsolved mysteries in astrophysics. Where do they come from? What forces accelerate them to such unimaginable speeds? And could understanding them unlock new physics that challenges everything we think we know about the universe? Level 38. Deep in the ocean, near hydrothermal vents where scorching hot water spews from the seafloor, scientists discovered one of the strangest creatures on Earth, the yeti crab. Covered in white, hair-like bristles that resemble fur, this bizarre crustacean looks more like a deep-sea monster than a typical crab. But what's even weirder than its appearance is the mystery surrounding why it has this fur in the first place. First discovered in 2005, the yeti crab, officially named Kiwa hirsuta, lives in the extreme environment of deep-sea hydrothermal vents, where temperatures can reach 400 degrees Celsius. Unlike most crabs, which have smooth shells, the yeti crab is covered in thick, hair-like filaments on its claws and body. Scientists initially thought these bristles might be used for filtering food from the water, but later studies suggested something even stranger. The fur may actually grow bacteria that the crab farms and eats. If true, this would mean the yeti crab cultivates its own food supply in one of the harshest environments on Earth. The bacteria might survive by feeding on the toxic minerals released by hydrothermal vents, turning deadly chemicals into a food source for the crab. Essentially, the yeti crab may farm its own bacterial garden right on its claws, one of the few known cases of deep-sea farming in nature. But despite years of study, scientists still aren't entirely sure how this process works, or if the bacteria provide all of the crab's nutrition. Some researchers suspect that the crab might also scavenge or feed on other small organisms near the vents. Another mystery is why its bristles glow under certain lighting conditions. Some theories suggest it might be a way to attract food or deter predators, but the true reason remains unknown. The yeti crab is a living example of how much we still don't know about life in the deep ocean. Could there be even stranger creatures living near hydrothermal vents, using biological processes completely unknown to science? Until we unlock the secrets of this hairy deep-sea enigma, the yeti crab remains one of the ocean's most bizarre and mysterious creatures. Level 39. We like to think of ourselves as rational beings, making decisions based on logic and reason. But what if free will, the ability to make independent choices, is just an illusion? Neuroscience and physics have raised serious questions about whether humans truly have free will, or if our thoughts and actions are completely determined by forces beyond our control. One of the biggest challenges to free will comes from neuroscience. In the 1980s, a famous experiment by scientist Benjamin Libet showed that the brain decides to act before we are consciously aware of making a decision. Using EEG scans, Libet found that electrical signals in the brain's motor cortex start firing milliseconds before a person reports making a conscious choice. This suggests that what we experience as a decision is actually just our brain catching up to a process that has already begun. If the brain makes decisions before we're aware of them, does that mean our choices are just automatic responses governed by brain chemistry and not actual free will? Some scientists argue that all human behavior can be explained by neural processes, genetics, and environmental influences, meaning that everything we do was already determined by the conditions that shaped us. But the challenge to free will doesn't stop with neuroscience. Physics also raises serious doubts. If the universe follows strict physical laws, then every particle in existence, including those in our brains, moves according to these laws. This would mean that all of our choices were set in motion since the beginning of time, like a chain reaction of cause and effect that we cannot escape. On the other hand, quantum mechanics introduces an element of randomness, but randomness is not the same as free will. It would just mean our actions are unpredictable, not necessarily chosen. Some philosophers and scientists argue that free will still exists in a different form. that even if our brain is following physical laws, we still own our decisions and experience them as real. Others believe we may need an entirely new understanding of consciousness and physics to explain how free will works. So, do we truly have control over our thoughts and actions? Or are we just biological machines playing out a script written by physics and biology? Until we fully understand the mind, the question of free will remains one of the deepest and most unsettling mysteries in science. Level 40. For decades, science fiction has imagined spaceships traveling faster than light, exploring distant galaxies in a matter of days. But is warp drive, a technology that bends space itself to allow faster-than-light travel, actually possible? According to our current understanding of physics, nothing can travel faster than light. Yet, some theories suggest that bending space-time itself might offer a loophole to this rule. The idea of a warp drive comes from Einstein's general relativity, which shows that space-time can be curved and stretched. Instead of moving through space at faster-than-light speeds, a warp drive would work by compressing space in front of a ship and expanding it behind, creating a warp bubble that carries the ship along. This would mean that the ship itself isn't actually moving faster than light. Space itself is doing the moving. One of the most famous theoretical models for this is the Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994. His equations showed that faster-than-light travel might be possible, but there's a huge problem. It would require an exotic form of negative energy, something that we don't know how to create. To make a warp bubble, we would need a material with negative mass, or a way to manipulate space-time in a way that modern physics does not currently allow. Some scientists think that small-scale warp effects might be possible in the future. NASA has even experimented with tiny distortions in space using high-energy physics. But we are nowhere near building an actual warp drive. If negative energy or exotic matter were discovered, it could change everything. But so far, these remain purely theoretical. There's also the question of what would happen to anything inside a warp bubble. Would it be protected from outside forces? Would it cause strange time effects, like traveling into the past? Since no one has ever built a working warp drive, we don't yet know the answers. For now, faster-than-light travel remains in the realm of science fiction. But if breakthroughs in quantum physics or space-time manipulation ever reveal a way to generate negative energy, warp drive might move from the impossible to the possible, allowing us to explore the universe in ways we can only dream of today. Level 41. The universe appears to be governed by four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces explain everything from the behavior of galaxies to the structure of atoms. But what if there is a fifth fundamental force, one that we haven't yet discovered? If such a force exists, it could change our entire understanding of physics, revealing hidden interactions that shape the universe in ways we never imagined. For decades, physicists have suspected that the four known forces might not be the full picture. The standard model of particle physics, which describes the fundamental building blocks of the universe, is incredibly successful. But it's also incomplete. It doesn't explain dark matter, doesn't include gravity in a quantum framework, and doesn't account for why the universe is expanding at an accelerating rate. These gaps have led many scientists to believe that there may be an additional, undiscovered force at work. One of the biggest clues that a fifth force might exist comes from anomalies in particle physics experiments. In 2016, researchers in Hungary detected unusual behavior in nuclear decay experiments, evidence of a strange new particle, nicknamed X17, which seems to behave in ways that don't fit with the known forces. If X17 is real, it could mean there is a new force-carrying particle, just as photons carry electromagnetism or gluons carry the strong nuclear force. This potential fifth force could be linked to an undiscovered dark sector of physics, possibly interacting with dark matter. The mysterious substance that makes up about 27% of the universe yet remains invisible to us. Dark matter itself is one of the biggest reasons to suspect a fifth force. Unlike normal matter, dark matter does not interact with electromagnetic forces, which means it doesn't emit, absorb, or reflect light. But it does have gravitational effects, shaping the way galaxies rotate and influencing cosmic structures. Some scientists believe that dark matter might have its own hidden force, a dark force that only interacts with dark matter particles. If true, this would mean the universe operates with an additional force that has so far remained undetected by our instruments. Then there's the question of gravity. Unlike the other three fundamental forces, gravity is incredibly weak compared to electromagnetism or the strong nuclear force. Some physicists have speculated that gravity might not be a force like the others at all, but instead a side effect of some deeper, unknown phenomenon. A fifth force could help explain why gravity is so much weaker than the other forces. Perhaps it is leaking into extra dimensions, or perhaps another force is acting to counterbalance its effects at certain scales. Another possibility is that the fifth force could be modifying gravity itself. The acceleration of the universe's expansion, currently explained by dark energy, could be the result of a new, repulsive force acting at cosmic distances. If such a force exists, it could help solve one of the greatest mysteries in cosmology: why the universe is expanding faster and faster instead of slowing down due to gravity. If a fifth force is real, it could open the door to new physics, new technologies, and possibly even new ways of understanding reality. Some radical ideas even suggest that such a force might play a role in consciousness, connecting the physical world with aspects of reality we don't yet understand. While this remains speculative, it highlights just how profound the discovery of a new fundamental force would be. It could affect everything from the nature of space-time to the deepest layers of our own perception. Right now, the search for a fifth force is one of the most exciting frontiers in physics. Scientists are conducting high-energy experiments, analyzing cosmic radiation, and studying atomic interactions in search of evidence. If we do discover an additional force, it could be the missing key to unifying our understanding of the universe, potentially bridging the gap between quantum mechanics and gravity. Until then, the question remains: is there a hidden force shaping the cosmos just beyond our reach? The answer could change everything. Level 42. At first glance, the universe seems like a vast, three-dimensional expanse filled with galaxies, stars, and planets. But what if reality isn't as three-dimensional as it appears? What if everything we see, touch, and experience is actually a kind of projection, like a cosmic hologram? This is the idea behind the holographic universe hypothesis, a theory suggesting that the fundamental nature of reality might be radically different from what we assume. The concept emerged from research in quantum physics and black hole studies, where scientists have found surprising mathematical hints that the universe may actually be a two-dimensional structure that only appears three-dimensional, much like a hologram on a credit card. The idea gained serious attention when physicists studying black holes made a strange discovery. They found that all the information about a black hole's contents could be encoded on its surface rather than being stored within its volume. This is known as the holographic principle, the idea that a higher dimensional reality can be described entirely by lower dimensional data. If this applies to black holes, some scientists believe it might apply to the entire universe. One way to think about it is to imagine a video game. When you play an open-world game, it feels like you're moving through a fully three-dimensional environment, but in reality, everything is stored as data on a flat computer chip. According to the holographic principle, the same could be true for the universe. Everything we experience might be the result of information encoded on a distant cosmic screen at the edge of the universe. If this theory is true, it could radically change our understanding of space, time, and even consciousness itself. It might help explain some of the deep puzzles in physics, such as why gravity behaves differently from other fundamental forces. Some physicists even speculate that reality itself could emerge from this underlying holographic structure. So, is the universe really a hologram? Right now, it's just a hypothesis, but it's one of the most mind-bending ideas in modern physics. If proven true, it could reshape everything we know about the nature of existence. Level 43. In everyday life, the word vacuum makes us think of empty space, nothingness, complete void, absolute zero. But in the strange world of quantum physics, empty space is anything but empty. Even in a perfect vacuum, tiny fluctuations in energy are constantly happening at the quantum level, producing what's known as zero-point energy, the lowest possible energy state that a system can have. This has led scientists to ask an intriguing question. Can we extract energy from a vacuum? quantum mechanics tells us that even in the emptiest space imaginable, virtual particles are continuously popping in and out of existence. These tiny fluctuations create a background energy field, which in theory could be tapped into as a limitless source of power. This concept is sometimes called vacuum energy extraction, and if it were possible, it could revolutionize human civilization, providing an endless supply of energy without fuel, pollution, or resource depletion. One of the biggest hints that vacuum energy is real comes from the Casimir effect, a phenomenon first predicted in 1948. When two uncharged metal plates are placed extremely close together in a vacuum, they experience a force pushing them toward each other, even though there's no external energy source. This happens because the plates block some of the quantum fluctuations between them, creating an energy imbalance that generates a tiny force. This is experimental proof that the vacuum has real energy, energy that, in theory, might be extracted. But turning this effect into a practical energy source is an entirely different challenge. The amount of energy involved in the Casimir effect is minuscule, far too small to be useful. Moreover, if vacuum energy could be extracted freely, it could lead to violations of fundamental laws of physics, including the conservation of energy. Some theories even suggest that tapping into vacuum energy in the wrong way could destabilize space itself, potentially leading to catastrophic effects. Despite these challenges, some physicists and engineers continue to explore the possibility of vacuum energy extraction, hoping that new breakthroughs in quantum field theory or exotic materials might one day unlock this hidden power source. Whether it's possible or not remains one of the greatest mysteries of modern physics, one that, if solved, could change the future of energy forever. Level 44. Laughter is one of the most universal human behaviors, yet scientists still don't fully understand why it exists. Unlike basic emotions like fear or anger, laughter doesn't have an obvious survival advantage. It's not necessary for finding food, avoiding danger, or reproducing. So why did evolution favor it? One theory is that laughter developed as a form of social bonding. When people laugh together, their brains release endorphins, strengthening social connections and promoting cooperation. This could explain why laughter is often contagious, and why we tend to laugh more in groups than when we're alone. Another idea is that laughter evolved as a way to signal safety. Early humans might have used laughter to reassure others after realizing a potential threat wasn't actually dangerous, creating a sense of relief and trust within a group. Some scientists believe that laughter plays a role in cognitive processing. Humor often involves recognizing contradictions, absurdities, or unexpected patterns, and laughter might help our brains handle this kind of information more efficiently. This could explain why jokes that subvert expectations tend to be the funniest, and why humor is closely linked to intelligence. But despite these theories, many questions remain. Why do different cultures find different things funny? Why do some people laugh uncontrollably in serious or inappropriate situations? And why does forced laughter, like in laughter yoga, still seem to improve mood, even when nothing is actually funny? For something so natural and instinctive, laughter is surprisingly complex. Scientists continue to study it, but for now, it remains one of the many mysteries of human nature. Level 45. The speed of light is one of the most fundamental constants in physics, measured at precisely 299,792,458 meters per second in a vacuum. According to Einstein's theory of relativity, it represents the ultimate speed limit of the universe. Nothing with mass can ever reach or exceed it. As an object approaches the speed of light, time slows down for it relative to an outside observer, and its energy requirements grow infinitely large. These principles have been tested and confirmed through countless experiments, making the speed of light one of the cornerstones of modern physics. But while we know how light behaves, we still don't know why it has this specific speed. Why not a faster or slower value? Most physical constants, like the mass of an electron or the strength of gravity, have explanations tied to deeper fundamental forces or physical properties. But the speed of light simply appears as a given value, one that seems arbitrary yet deeply woven into the fabric of reality. If it were slightly different, the entire universe might be unrecognizably different. Some physicists speculate that if the speed of light were just a little higher or lower, atoms might not form, stars might not ignite, or chemical interactions could unfold at entirely different rates. possibly making life as we know it impossible. This suggests that the speed of light is somehow fine-tuned to allow for a stable universe, a concept that raises profound questions about the nature of reality. But even if it is fine-tuned, was it always this speed, or has it changed over time? Some theories propose that in the early universe, light traveled much faster than it does today. This idea could help explain some of the mysteries of cosmology, such as the horizon problem, a paradox where distant parts of the universe appear to have the same temperature, despite being too far apart to have exchanged information at the speed of light. If light used to move faster in the past, then these regions could have once been in contact, allowing them to reach thermal equilibrium. However, this idea remains speculative, as no conclusive evidence has shown that the speed of light has ever varied. Another deep mystery is why the speed of light is the same for all observers, regardless of their motion. Unlike sound or water waves, which depend on the medium they travel through, light behaves differently. It moves at the same speed no matter how fast the observer is moving relative to it. This concept, first proven by the Michelson-Morley experiment in 1887, shattered classical physics and led directly to Einstein's special theory of relativity. But why the universe is structured this way remains an open question. Some physicists believe the explanation lies in the very geometry of space-time itself, while others think it could point to unknown properties of the vacuum. There's also the question of whether the speed of light is truly the fastest possible speed in the universe. Some theoretical physics models suggest that tachyons, hypothetical particles that always travel faster than light, could exist. If they do, they would violate causality, allowing for time travel and paradoxes. So far, no tachyons have been detected, but the possibility remains an open area of research. Meanwhile, quantum mechanics adds even more strangeness. Quantum entanglement allows two particles to affect each other instantly, no matter how far apart they are, appearing to violate the cosmic speed limit. While this doesn't allow for faster-than-light communication, it suggests that information in the quantum world behaves in ways we don't yet understand. The speed of light governs everything in the physical universe, from the way galaxies evolve to the limitations of human technology. It determines the structure of reality as we know it, yet its precise nature remains elusive. Is it truly a fixed constant, or is it a consequence of deeper, hidden laws of physics? Could it one day be manipulated, opening the door to entirely new technologies? For now, the reason why light moves at this exact speed remains one of the greatest mysteries in science. Level 46. In the vast emptiness of space, spacecraft follow the precise laws of physics, except when they don't. The Pioneer anomaly is one of the strangest unsolved mysteries in space exploration. When NASA's Pioneer 10 and Pioneer 11 spacecraft were launched in the 1970s to explore the outer solar system, and beyond, they followed their expected trajectories for decades. But as they traveled farther from the sun, scientists noticed something strange. Both probes were slowing down slightly more than expected, as if some unknown force was tugging at them. The effect was small, just a tiny acceleration toward the sun, but it was measurable and completely unaccounted for by any known force. Scientists spent years trying to determine whether this slowdown was caused by gravitational effects, solar radiation pressure, gas leaks, or even an error in their tracking systems. Yet, none of these explanations fully accounted for the anomaly. One of the first suspects was thermal radiation. The spacecraft generated heat from their power sources, and if this heat was emitted asymmetrically, it could, in theory, create a tiny thrust that altered their motion. Some studies suggested that this effect could explain the anomaly, but other scientists argue that the thermal explanation doesn't fully match the data. Another idea is that the Pioneer anomaly might hint at a flaw in our understanding of gravity itself. If gravity behaves slightly differently at vast distances, or if unknown forces are at play, this could explain why the probes are moving in unexpected ways. Some researchers have even proposed that this could be evidence of a new fundamental force, or even modifications to Einstein's theory of gravity. More speculative theories suggest that the Pioneer anomaly might be caused by dark matter, the mysterious invisible substance that makes up most of the universe's mass. If the spacecraft were moving through a cloud of dark matter, subtle interactions might be altering their motion in ways we don't yet understand. There's also the possibility that the anomaly is linked to quantum effects in empty space, Some hypotheses propose that space itself isn't a true vacuum, but contains tiny fluctuations of energy that could affect spacecraft in unexpected ways. If this idea is correct, it could revolutionize our understanding of the fundamental nature of space. For years, the Pioneer anomaly remained one of the most stubborn mysteries in astrophysics, raising deep questions about physics, gravity, and the limits of our knowledge. While some scientists believe thermal radiation explains most of the effect, the debate isn't entirely settled. If it turns out to be something more than just heat, it could lead to a new understanding of the forces governing the universe. Level 47. Synesthesia is one of the strangest and least understood phenomena of the human mind. It's a neurological condition where the senses become blended. People with synesthesia might see colors when they hear music, taste words, or associate numbers with personalities. While it might sound like something out of science fiction, synesthesia is a real, documented condition that affects a small percentage of the population. But despite its existence being well established, scientists still don't fully understand why it happens or what causes it. One of the leading theories suggests that synesthesia occurs due to increased connectivity between different sensory regions in the brain. In most people, sensory processing areas, like vision, sound, and taste, are relatively separate. But in synesthetes, these areas appear to be more interconnected, causing an involuntary blending of experiences. This could be due to genetic factors, as synesthesia often runs in families, suggesting it may be a heritable trait embedded in brain structure. However, this doesn't explain why some people develop synesthesia later in life, or why certain forms seem to appear randomly. Another mystery is whether everyone is born with synesthesia and loses it over time. Some researchers believe that infants experience the world in a highly interconnected way, where all senses blend together, but as the brain develops, these connections become more specialized and separate. If this is true, then synesthetes might simply retain some of these early neural pathways into adulthood, while others lose them. However, this is still an open question, as studying sensory perception in newborns is extremely difficult. The variety of synesthetic experiences also raises more questions. Some forms are consistent and lifelong. For example, someone with grapheme color synesthesia might always see the letter A as red and the number 7 as green, with the associations never changing. But in other cases, synesthetic experiences can shift or fade over time, leading scientists to wonder if the brain is capable of rewiring itself to suppress or enhance these connections. There are even reports of people developing synesthesia after brain injuries or psychedelic drug use, suggesting that the potential for sensory blending might exist in everyone, but is usually dormant. There's also the question of whether synesthesia provides any cognitive advantages. Some studies suggest that synesthetes tend to have better memory, particularly for things that involve their unique associations. For example, someone who sees colors when reading words might be able to recall information more easily, because their brain encodes it in multiple ways. Some synesthetes also report enhanced creativity, and a disproportionate number of them are artists, musicians, or writers. This has led to speculation that synesthesia might have played a role in human evolution, potentially giving some individuals a richer sensory experience that helped with communication, artistic expression, or even survival. But despite these insights, major mysteries remain. Why do different synesthetes experience different types of sensory blending? Why do some people report mild, fleeting synesthetic experiences, while others have strong, lifelong versions? And could it be that all humans experience weak forms of synesthesia without realizing it? For example, associating high-pitched sounds with sharp objects or darker colors with lower musical notes. Level 48. Deep beneath the ocean's surface, where sunlight never reaches and the pressure is crushing, life has found a way to thrive. But among the strangest creatures discovered in these extreme depths is the zombie worm, or Osedax, a bizarre species that survives by feeding on the bones of dead whales. What makes these worms truly mysterious is how they digest bones without having a mouth or stomach. Instead of eating in a conventional way, zombie worms secrete acids that break down the bone, allowing them to extract nutrients with the help of symbiotic bacteria living inside their bodies. But even though this process is partially understood, scientists still don't know how these worms locate whale carcasses in the vast, featureless deep sea. Since whale falls, dead whales sinking to the ocean floor, are rare and scattered across thousands of miles, it's unclear how Osidax finds them so efficiently. Adding to the mystery, the discovery of Osidax fossils suggests these worms have existed for millions of years, meaning they likely survived through periods where whale populations were much lower than today. This raises the question, what did they feed on before whales evolved? Some researchers suspect they might have originally fed on the bones of giant marine reptiles like plesiosaurs during the age of dinosaurs, adapting over time to new food sources. But if that's the case, why haven't we found clear fossil evidence of Osidax on prehistoric bones? There's also the question of how these worms reproduce. Male Osidax are microscopic and live inside the bodies of females in a bizarre parasitic relationship. But it's unclear how their reproductive cycle is triggered and whether they rely on external environmental cues. Despite living in some of the most extreme and least explored parts of the planet, zombie worms have been thriving for millions of years. Yet, how they locate food, how they survive before whales, and the details of their reproduction all remain unsolved questions, making them one of the many strange and unexplained creatures of the deep. Level 49. Intelligence is one of the most complex and debated concepts in science. We recognize it when we see it, yet defining it precisely remains a challenge. Is intelligence simply the ability to solve problems? Is it the capacity for learning, memory, and reasoning? Or does it involve creativity, social awareness, and even consciousness? Despite decades of research in psychology, neuroscience, and artificial intelligence, there is still no single agreed-upon definition of what intelligence truly is. One of the main difficulties in defining intelligence is that it seems to exist in many different forms. Human intelligence includes logical reasoning, emotional understanding, abstract thinking, and the ability to plan for the future. Animal intelligence, on the other hand, varies widely. Crows use tools, dolphins recognize themselves in mirrors, and octopuses solve puzzles. Even within humans, intelligence is difficult to quantify. Traditional IQ tests measure logical and mathematical ability, but they don't necessarily capture creativity, social intelligence, or adaptability, traits that are just as important for success in the real world. Then there's the question of artificial intelligence. Computers can now outperform humans in tasks like playing chess, recognizing faces, and even writing text. But does that mean they are intelligent? Many argue that AI is still fundamentally different from human intelligence because it lacks understanding, self-awareness, and the ability to form independent goals. Others believe intelligence is simply a matter of processing information efficiently, meaning AI could eventually surpass human intelligence in every way. But if an AI can simulate intelligence so well that it becomes indistinguishable from human thought, does it matter whether it's truly aware or not? Some researchers believe intelligence is not a single trait, but a collection of different abilities that emerge in response to challenges. Howard Gardner's theory of multiple intelligences suggests that intelligence comes in many forms, including linguistic, musical, spatial, kinesthetic, interpersonal, and intrapersonal intelligence. If this is true, then measuring intelligence through a single number, like an IQ score, may be an oversimplification. There is also a deeper mystery. Where does intelligence actually come from? How does a collection of neurons in the brain give rise to conscious thought? Scientists have mapped many regions of the brain involved in memory, reasoning, and problem solving, but no one has found the precise mechanism that generates intelligence itself. Some theories suggest intelligence emerges from the complexity of neural networks, while others propose it is linked to quantum processes at the microscopic level. As we continue to study the brain, AI, and the intelligence of other species, we may eventually reach a clearer understanding of what intelligence truly is. But for now, intelligence remains one of the greatest unsolved mysteries, a concept that shapes our world, yet one that we still struggle to define. Level 50. Tabby's star is one of the strangest stars ever observed. Located about 1,470 light-years away in the constellation Cygnus, it first gained attention in 2015 when astronomer Tabitha Boyajian and her team noticed something unusual. Its brightness was fluctuating in ways that defied explanation. Most stars dim periodically due to planets passing in front of them, but the dimming of Tabby's star was irregular, extreme, and unpredictable. Sometimes the star's brightness would drop by as much as 22%, far more than what a typical planet could cause, and these dips didn't follow any obvious pattern. Scientists scrambled to find an explanation, but every natural cause seemed inadequate. One of the first possibilities considered was a swarm of comets, but for that to be true, there would need to be an impossibly large number of them in orbit around the star. Another theory suggested dust clouds or fragments from a planetary collision, but infrared observations showed no excess heat, something we would expect from such an event. Then came the most exciting and controversial idea: an alien megastructure. Some researchers speculated that the unusual dimming could be caused by a Dyson sphere, a hypothetical structure built by an advanced civilization to capture energy from its star. While no solid evidence supports this theory, the strange behavior of Tabby's star fueled speculation about the possibility of intelligent extraterrestrial activity. In response, astronomers used radio telescopes to scan for any artificial signals from the star, but none have been detected so far. The mystery deepened when further studies showed that Tabby's star isn't just dimming in short bursts. It appears to be gradually fading over time. Over a century of observational records suggest that the star has been losing brightness at an unusual rate, something not seen in normal stellar evolution. This long-term dimming remains unexplained, adding another layer of mystery to an already bizarre celestial object. More recent observations suggest that the dimming may be caused by uneven dust clouds, which block different wavelengths of light at different intensities. This is currently the leading explanation, but it still doesn't fully account for the star's extreme and unpredictable dips in brightness. Some astronomers believe there may be multiple factors at play, including an unusually complex planetary system, unknown cosmic phenomena, or even processes we have yet to discover. Despite years of study, no single theory fully explains what's happening with Tabby's star. It remains one of the most perplexing and intriguing objects in the galaxy, challenging our understanding of how stars behave. Whether the answer lies in an unknown astronomical phenomenon or something even more extraordinary, the mystery of Tabby's star continues to captivate scientists and the public alike. Level 51. Quantum tunneling is one of the most bizarre and counterintuitive phenomena in physics, challenging our classical understanding of motion, barriers, and energy. In the macroscopic world, if an object encounters a wall or an obstacle and doesn't have enough energy to pass over it, it stops or bounces back. Imagine trying to roll a ball up a steep hill. Unless it has enough speed, it won't make it to the other side. But in the strange world of quantum mechanics, particles don't behave like tiny billiard balls. They also have wave-like properties, and these waves allow them to do something that seems impossible: pass through barriers that, according to classical physics, should be impenetrable. At the heart of this phenomenon is the wave function, a mathematical description of a particle's possible locations and behaviors. In quantum mechanics, particles like electrons, protons, and even atoms don't exist as fixed points in space. Instead, they are described by a probability wave, meaning that their exact position is not determined until they are measured. When this wave encounters a barrier, instead of stopping completely, it extends into and sometimes through the barrier. If the barrier is thin enough, part of the wave can emerge on the other side, which means there is a probability that the particle will appear beyond the barrier, even though it never had enough energy to overcome it in a classical sense. This effect is known as quantum tunneling. Quantum tunneling isn't just a theoretical quirk. It plays a crucial role in many real-world phenomena. One of its most important applications is in nuclear fusion, the process that powers the sun and stars. In classical physics, the positively charged nuclei of atoms should repel each other due to electrostatic forces, preventing them from coming close enough to fuse. However, because of quantum tunneling, these nuclei can sometimes pass through this energy barrier and merge, releasing vast amounts of energy in the process. Without quantum tunneling, the sun would not shine, and life as we know it would not exist. Beyond astrophysics, quantum tunneling is also essential to modern technology. Scanning tunneling microscopes, for example, use this effect to image individual atoms on surfaces, allowing scientists to study materials at an unprecedented level of detail. In electronics, transistors in modern computer chips rely on tunneling to switch between states, enabling faster and more efficient processing. Flash memory, used in USB drives and solid-state drives, also exploits quantum tunneling to store data. Despite its practical applications, quantum tunneling raises profound philosophical and scientific questions. How does a particle decide when to tunnel? Does it momentarily vanish inside the barrier, or does it take an unknown path through higher dimensions? Some interpretations of quantum mechanics suggest that tunneling occurs because particles explore multiple possible paths simultaneously, existing in a superposition of states until they emerge on the other side. Others propose that quantum mechanics allows for brief violations of classical energy conservation, enabling the particle to momentarily borrow energy to pass through the barrier before settling back into a lower energy state. Even stranger, quantum tunneling appears to happen instantaneously. Experiments suggest that a particle may jump through a barrier without actually traveling through it at any measurable speed. This challenges our conventional notions of space, time, and causality, hinting that our understanding of reality itself may be incomplete. There are still many unanswered questions about quantum tunneling, and it remains an active area of research in quantum physics. Could it be harnessed for new energy sources or faster-than-light communication? Could it help us understand the true nature of time and space? As we continue to probe the limits of quantum mechanics, tunneling remains one of the most fascinating and mysterious aspects of the universe, blurring the line between the possible and the impossible. Level 52. Venus, often called Earth's twin due to its similar size and composition, has long been dismissed as a candidate for life because of its extreme surface conditions, temperatures hot enough to melt lead, and an atmosphere dominated by thick clouds of sulfuric acid. However, scientists have turned their attention to a different possibility: the planet's upper atmosphere. At about 50 kilometers above Venus's surface, the temperature and pressure are much more Earth-like, creating a region where, hypothetically, life could exist. In 2020, researchers detected traces of phosphine gas in Venus's clouds, a chemical often associated with biological activity on Earth. This discovery sparked excitement and debate. While phosphine can be produced through non-biological means, such as volcanic activity or lightning, no known chemical processes on Venus could explain the observed levels. If life does exist in Venus's atmosphere, it would likely take the form of microbes capable of surviving in highly acidic conditions. Some extremophiles on Earth, such as acid-resistant bacteria, offer a potential model for how life could persist in such an environment. The idea isn't entirely new. Carl Sagan proposed the possibility of Venusian cloud life back in 1967. Despite the intrigue, skepticism remains. Subsequent studies have questioned the accuracy of the phosphine detection, and alternative explanations have been proposed. More data is needed to determine whether the signal was real, and if so, whether it has a biological origin. Upcoming missions aim to explore Venus in greater detail, possibly providing answers to one of the most intriguing scientific mysteries. Could something be alive in the clouds of Venus? Level 53. Some organisms exhibit bizarre survival mechanisms that defy our understanding of life and death. Tardigrades, microscopic creatures known as water bears, can survive in the vacuum of space, endure radiation thousands of times stronger than what would kill a human, and enter a state called cryptobiosis, where they essentially shut down all biological processes and later revive as if nothing happened. Wood frogs can freeze solid in the winter, their hearts stopping completely, only to thaw and resume life in the spring. Certain bacteria have been revived from permafrost after being dormant for thousands, even millions of years. Lobsters don't seem to age in the same way other animals do, continuously growing and molting, raising the question of whether they might be biologically immortal under the right conditions. But how do these creatures halt biological decay, repair damaged cells, and resume life after extreme conditions? What mechanisms allow some to cheat death, while other organisms, especially humans, inevitably succumb to aging, disease, and cellular breakdown? Scientists are only beginning to understand the molecular and genetic processes behind these abilities. Could unlocking these secrets lead to breakthroughs in human longevity, suspended animation, or even reversing death itself. If some forms of life can survive the extremes of space, deep-sea pressures, or total metabolic shutdown, what does that mean for the limits of biology? Are there organisms on Earth that have already achieved something close to immortality? And could we one day apply their survival strategies to humans? The answers to these questions could redefine what it means to be alive. Level 54. Neutron stars are some of the most extreme objects in the universe, formed when massive stars explode in supernovae and leave behind ultra-dense remnants. These remnants are so dense that a single sugar cube-sized piece of neutron star material would weigh billions of tons on Earth. They spin rapidly, sometimes hundreds of times per second, and emit beams of electromagnetic radiation, which make them detectable as pulsars. However, neutron stars exhibit a strange and unexpected phenomenon known as a glitch. These glitches are sudden, unpredictable jumps in their rotation speed. Normally, neutron stars lose energy over time, causing them to gradually slow down. But during a glitch, this slowdown is abruptly interrupted, and the star's rotation rate suddenly increases. After the glitch, the neutron star may return to its previous slowdown rate, but the cause of the event remains an open question. One of the leading theories to explain neutron star glitches involves their exotic internal structure. A neutron star isn't just a solid sphere. It has layers, including a crust and an inner core. The outer crust is rigid, while the interior contains a superfluid, a bizarre quantum state of matter where particles move without friction. In this model, as the neutron star slows down over time, the superfluid inside does not slow down at the same rate as the crust due to the lack of friction. This creates a difference in rotational speed between the superfluid and the rest of the star. Eventually, the difference becomes too large, and the superfluid suddenly transfers some of its angular momentum to the crust, causing the entire star to spin up in a glitch. Another theory suggests that the crust of the neutron star itself could be responsible. Over time, stress builds up in the crust due to the star's intense gravitational and magnetic fields. When the stress becomes too great, the crust may suddenly crack, releasing energy and altering the star's rotation. This idea is similar to how earthquakes occur on Earth, but at an extreme cosmic scale. Despite these theories, neutron star glitches remain mysterious. Not all neutron stars glitch, and the timing of glitches is unpredictable. Some stars experience frequent glitches, while others go for decades without any. Understanding these events could help scientists learn more about the exotic physics at play inside neutron stars, where matter exists in states not found anywhere else in the universe. By studying glitches, astrophysicists hope to gain deeper insight into quantum mechanics, nuclear physics, and the behavior of matter under extreme conditions. These strange events challenge our understanding of how the fundamental forces of nature interact, making them one of the great unsolved mysteries of modern astrophysics. Level 55. Some people claim to remember events that never actually happened, a strange and unsettling phenomenon often called the Mandela effect. This name comes from the widespread but false memory that Nelson Mandela died in prison in the 1980s, even though he was released and lived until 2013. People vividly recall news coverage, speeches, and other details that never existed. But how can so many people misremember the same thing? One explanation comes from false memories, a well-documented psychological effect. Our brains do not store memories like a video recorder. Instead, they reconstruct events each time we recall them. Over time, details shift, merge, or distort based on new information. This happens individually, but social reinforcement can amplify it. When people discuss and validate each other's false memories, they strengthen them, making the incorrect details feel even more real. Another theory involves confabulation, where the brain fills in missing information with fabricated but believable details. This is common in people with brain injuries, but it also happens in everyday life. Small mistakes in memory can spread and become real to those who believe them. Some researchers suggest that misinformation and collective memory shifts play a role. When an incorrect fact appears in books, TV shows, or online, it can become ingrained in public knowledge. For example, many people incorrectly recall the famous line from Snow White as "Mirror, mirror on the wall," when the actual line is magic mirror on the wall. Pop culture and repetition reinforce the false version. One of the most bizarre theories is that these false memories result from parallel universes or alternate timelines. Some believe that shifts in reality cause certain groups to remember a past that no longer exists. While there is no scientific evidence for this, the idea is popular among those who experience multiple false memories that feel inexplicably real. Neuroscience also provides clues. Studies show that the brain is highly susceptible to suggestion, and memories can be easily manipulated. Experiments have demonstrated that simply hearing a different version of an event can cause people to remember things that never happened. The hippocampus, responsible for storing memories, sometimes confuses imagination with reality. Ultimately, the phenomenon of remembering events that never happened reveals the fragility of human memory. While some explanations are grounded in psychology and neuroscience, the experience itself remains deeply unsettling for those who are convinced their memories are accurate. Whether it's a trick of the mind or something more mysterious, this remains one of science's strangest puzzles. Level 56. Why do different animals and even humans experience time at different speeds? Some creatures, like birds, insects, and small mammals, appear to perceive the world in slow motion, reacting to stimuli far more quickly than humans. A housefly, for example, can dodge an incoming slap with near instantaneous precision, as if time were running slower for it. Meanwhile, larger animals such as elephants seem to live in a much more sluggish perception of reality, moving slowly and reacting at a different pace. Even among humans, time perception is inconsistent. Time seems to stretch during moments of extreme fear or stress, such as in car accidents. Yet it speeds up as we age, making childhood summers feel endless and adult years blur together. Certain drugs, meditation practices, and neurological conditions can also manipulate time perception, leading to experiences where minutes feel like hours or entire days vanish in what feels like an instant. Scientists have proposed multiple explanations for this strange phenomenon, but none provide a complete answer. One theory suggests that an organism's metabolic rate plays a crucial role. Animals with fast metabolisms, such as small birds and rodents, process information more quickly, making the external world seem slower in comparison. This might explain why a fly dodging a swatter seems to react in an instant. It may be experiencing reality at a finer resolution than we do. Conversely, animals with slower metabolisms may experience time in longer intervals, leading to more sluggish reactions. Another idea is that time perception is linked to an organism's neural processing speed. The faster a brain can process visual and sensory information, the more frames per second it effectively perceives, allowing it to take in more detail in the same objective amount of time. If this is true, different species may be living in vastly different subjective versions of reality, where 1 second for one creature may feel like an eternity for another. The mystery deepens when considering time perception in humans. Why does time seem to accelerate as we grow older? One possibility is that our brains measure time relative to the total length of our lived experience. For a 5-year-old, 1 year is a massive 20% of their life, while for a 50-year-old, it's only 2%. This means each new year feels progressively shorter as we age. However, there are deeper, less understood mechanisms at play. Experimental studies suggest that the more novel experiences we have, the slower time appears to pass in retrospect. This could explain why childhood, which is full of first-time experiences, feels longer in hindsight, whereas adulthood, often marked by routine, seems to fly by. Similarly, when the brain enters survival mode, such as during a traumatic or life-threatening event, it appears to process sensory information with extreme efficiency, creating the illusion of slow motion. This effect has been documented in soldiers, extreme athletes, and survivors of accidents who recall seeing every detail unfold in seemingly elongated time. This raises an even more mind-bending question. If time perception is flexible, could we one day learn to control it? Some researchers are exploring whether meditation, brain stimulation, or pharmacological interventions could alter the brain's perception of time, effectively allowing us to slow down or speed up our personal experience of reality. If future technologies could hack time perception, Humans might one day experience seconds as if they were hours, gaining more time to react in crucial moments, or even prolonging subjective life experience. But for now, the exact mechanism behind why different beings experience time so differently remains an open mystery, blending neuroscience, evolution, and the fundamental nature of how we interact with reality itself. Level 57. Scientists have long debated the origin of water on Earth, and despite extensive research, the answer remains one of the great mysteries of planetary science. The most common hypothesis is that Earth's water came from asteroids or comets that collided with the planet billions of years ago. These celestial bodies contain ice, and when they impacted the young Earth, they could have delivered vast amounts of water to its surface. However, there are problems with this theory. The isotopic composition of Earth's water does not perfectly match that of comets, suggesting that they were not the primary source. Another theory suggests that water was present in Earth's formation from the very beginning. Some scientists propose that water was locked within the minerals of the protoplanetary disk that formed Earth, gradually being released through volcanic activity and outgassing. This would mean that water was always part of Earth's chemistry, rather than something delivered later. Recent studies have even suggested that water may have been preserved deep within Earth's mantle since the planet's formation. Adding to the mystery, some research points to a combination of both external and internal sources. It is possible that asteroids and comets contributed water, but a significant portion could have also originated from within the planet itself. The question remains, how did Earth end up with so much water when other rocky planets in the solar system, like Mars and Venus, have so little? Understanding where Earth's water came from is not just about our own planet, it also affects the search for habitable worlds elsewhere in the universe. If water delivery is common through asteroid impacts, then many exoplanets could have oceans just like Earth. However, if it requires unique geological conditions, then truly Earth-like planets may be rare. Despite decades of investigation, the precise origins of Earth's water remain uncertain. Scientists continue to analyze meteorites, study deep-sea minerals, and run simulations of planetary formation to uncover the answer. Until then, the question of where Earth's water truly came from remains one of the most intriguing and unsolved mysteries in science. Level 58. Scientists have classified many states of matter beyond the familiar solid, liquid, and gas, including plasma, Bose-Einstein condensates, and even exotic forms like quark-gluon plasma. But what if there are entirely new, naturally occurring states of matter that exist somewhere in the universe, completely unknown to us? Could there be materials or physical structures forming under extreme conditions that defy our current understanding of atomic and subatomic behavior? One possibility is that dark matter itself could have states we have never encountered. While we still do not know exactly what dark matter is made of, some theories suggest it could clump together to form exotic, stable structures that interact in ways we cannot currently measure. If dark matter forms complex configurations, it could mean that entire planets, or even star-like objects, exist in an invisible, undetectable form. Could there be dark matter condensates floating through space, behaving like an entirely new form of physics? Another intriguing idea is that space-time itself might have properties of matter under certain conditions. Some physicists propose that space-time could act as a kind of superfluid at a quantum level, meaning it could flow and behave similarly to a liquid under the right circumstances. If true, this could change our understanding of black holes, cosmic expansion, and even gravity itself. What if certain regions of the universe contain hidden layers of space-time, behaving in a way we haven't even begun to explore? Inside neutron stars, which are some of the densest objects in the universe, matter is compressed so intensely that atoms themselves collapse, forming a sea of neutrons. But some scientists believe that even weirder things could happen at these extreme densities. There could be entirely new, super-dense crystalline structures made of subatomic particles, what some have called hypercrystals. These structures might be stronger than anything found on Earth, and could hold secrets about the fundamental building blocks of reality. Then there's the idea of preon matter. Current physics suggests that quarks, which make up protons and neutrons, are the smallest known fundamental particles. But some theories propose that quarks themselves could be composed of even tinier building blocks called preons. If preons exist, then there might be an entire hidden layer of physics beneath what we currently understand. Could there be entire forms of matter composed of these hypothetical particles waiting to be discovered? If we ever manage to detect or create one of these unknown states of matter, it could completely reshape science and technology. Imagine if we found materials that could withstand extreme forces, conduct energy in ways never thought possible, or even reveal new laws of physics. The universe could be filled with matter that exists outside of anything we have ever encountered, hidden in places where our current tools simply cannot reach. For now, these ideas remain purely theoretical. But the more we explore the cosmos and push the boundaries of physics, the more we may find that nature has many surprises in store, some of which might completely redefine what we thought matter could be. Level 59. Black holes are often thought of as cosmic vacuum cleaners, devouring everything that crosses their event horizon. But what if, instead of being just destructive forces, they could be harnessed as an energy source? Some physicists believe that black holes might be among the most powerful energy generators in the universe. One theoretical method for extracting energy from a black hole involves the Penrose process. This idea, proposed by physicist Roger Penrose, suggests that energy can be extracted from a rotating black hole's ergosphere, the region just outside the event horizon where space itself is being dragged by the immense gravitational pull. In theory, if an object is sent into this region in the right way, it could split into two parts, one falling into the black hole and the other escaping with more energy than the original object had. This would essentially allow energy to be stolen from the black hole's rotation. Another potential method is the Blandford's-Najek process, which involves magnetic fields interacting with the spinning black hole. If a black hole is surrounded by an accretion disk, a swirling mass of matter being pulled toward the event horizon, strong magnetic fields can form. These magnetic fields, coupled with the black hole's rotation, could extract energy and convert it into powerful jets of radiation and particles. Some astrophysicists believe that these jets, which shoot out at nearly the speed of light, could be harnessed for energy. Then there's the idea of Hawking radiation, proposed by Stephen Hawking. Unlike the other methods which involve extracting energy from rotation, this process involves quantum mechanics. Near the event horizon, particle-antiparticle pairs spontaneously appear due to quantum fluctuations. Normally, these pairs annihilate each other, but if one falls into the black hole while the other escapes, the black hole loses a tiny fraction of its mass. This slow evaporation could, in theory, be used as an energy source if a way to capture the escaping particles was developed. While these ideas are fascinating, they remain theoretical. Extracting energy from black holes would require technology far beyond what currently exists. Even if it were possible, getting close enough to a black hole to set up an energy extraction system would pose extreme challenges due to its immense gravitational pull and radiation. Still, black holes represent an untapped frontier in energy generation, and if humanity ever develops the means to harness them, they could provide almost limitless power. Level 60. Have you ever stood near the edge of a cliff, a tall building, or a train platform and felt a sudden, inexplicable urge to jump? Not because you actually wanted to, but because, for a fleeting moment, your brain seemed to suggest the possibility. This eerie and unsettling sensation is known as l'appel du vide, French for the call of the void. It's an experience reported by many people, yet it remains one of the most mysterious and least understood quirks of human cognition. Psychologists and neuroscientists have debated why this happens, and several theories attempt to explain it. One possibility is that it's a counterintuitive survival mechanism. Instead of being a suicidal impulse, it might actually be the brain's way of reinforcing the desire to stay alive. By briefly simulating a dangerous action, the brain may be testing and strengthening your instinct for self-preservation. Essentially, when you recognize a threat, your mind automatically considers an action related to it before rejecting it outright, making sure that you remain cautious and safe. Another theory suggests that this phenomenon arises due to a miscommunication between different parts of the brain. The conscious mind, responsible for rational decision-making, might momentarily misinterpret a split-second danger assessment made by the subconscious mind. When you recognize the potential for harm, your brain quickly registers and acknowledges the threat. But somewhere in that process, the simple awareness of danger gets briefly misinterpreted as a suggestion to act on it. This could explain why people feel disturbed after experiencing the call of the void, because they know they have no desire to harm themselves, yet their brains still produce the thought. Some researchers also connect this experience to intrusive thoughts, which are random, unwanted thoughts that pop into our minds unexpectedly. Intrusive thoughts are not necessarily reflective of a person's actual desires, but rather strange misfires in cognitive processing. Just as someone might suddenly think of saying something inappropriate in a quiet room without actually wanting to do it, the call of the void could be another variation of this mental phenomenon. Even though many people have felt this sensation, it is still rarely discussed in scientific literature, leaving it largely unexplored. The exact mechanisms behind it remain unknown, making it one of the more mysterious quirks of human psychology. Whether it's a biological safeguard, a cognitive glitch, or something else entirely. The call of the void is a fascinating reminder that our minds are still full of secrets waiting to be unraveled. Level 61. What if I told you that our entire universe, everything we know, could actually be inside a black hole? This might sound like science fiction, but some physicists believe it's possible. Let's break it down. A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. The boundary of a black hole is called the event horizon, and beyond this, we assume everything is crushed into a singularity, a point of infinite density. But what if that's not the full story? Some theories suggest that when a massive star collapses and forms a black hole, instead of everything being crushed into a singularity, a new universe could emerge inside. The idea is that the core of the black hole might bounce into a new form of space-time, creating an entirely new reality on the other side of the event horizon. Physicists like Nikita Poplavsky propose that the Big Bang could have been the result of a black hole forming in a parent universe. Essentially, every black hole might be the seed of a new universe, and our own cosmos could be inside one right now. The expanding universe behaves a lot, like the way objects falling into a black hole would experience time differently from the outside world. The laws of physics inside black holes are unknown, but they could allow for new universes to form. If we are inside a black hole, could we ever leave? The event horizon would prevent anything from escaping back to the parent universe. So even if we were inside one, we would never be able to prove it from the outside. Level 62. One of the most mind-bending questions in modern science and philosophy is whether our universe is actually a computer simulation, a digital construct created by an advanced civilization. This idea, often referred to as the simulation hypothesis, suggests that reality as we know it might be an artificial illusion rather than a fundamental physical truth. The idea of reality being an illusion is not new. Philosophers like Plato, with his allegory of the cave, and Descartes, who questioned whether we could trust our senses, have explored this question for centuries. However, the modern version of the simulation theory was most famously proposed by Nick Bostrom, a philosopher at Oxford University, in his 2003 paper, Are You Living in a Computer Simulation? Bostrom's argument is based on probability. He suggested that at least one of the following statements must be true. Civilizations never reach the level of technology required to run realistic simulations. Advanced civilizations lose interest in running simulations of past human lives. We are almost certainly living in a simulation. If advanced civilizations exist and can create highly realistic simulations, then there could be billions or even trillions of simulated realities, making it statistically likely that we are inside one right now. Some scientists believe there are clues within physics that suggest our reality might be programmed. In physics, space and time appear to be made of discrete units at the smallest scales, like pixels in a video game. The Planck length, the smallest meaningful unit of space, and the quantization of energy suggest the universe may have a resolution limit, similar to a digital screen. Quantum indeterminacy, the idea that particles don't have definite states until observed, is eerily similar to how video games render only what is needed in real time. The famous double-slit experiment suggests that reality behaves differently when it's being observed, almost like a program optimizing performance. The universe seems to be written in mathematical code. Max Tegmark, a physicist at MIT, suggests that reality is best understood as a mathematical structure, which could be a sign that it's a program simulation. Even scientists like James Gates have found error-correcting codes, similar to those used in computers, embedded in the equations of fundamental physics. If we are in a simulation, are there ways to test or break out of it? Some propose looking for glitches in reality. If we ever detect inconsistencies in the laws of physics, it could be a sign of a simulated universe. Others suggest finding limits to computational power. A simulation would have processing constraints, meaning the universe may have built-in shortcuts or simplifications. Some even suggest running deep computational experiments to see if reality behaves unexpectedly. While the idea is fascinating, many physicists and philosophers disagree with the simulation hypothesis. There's no conclusive proof that we are in a simulation, only thought experiments and patterns that could be explained in other ways. Simulating an entire universe at such complexity would require an astronomical amount of computational power, far beyond anything we can conceive. Even if physics could be simulated, how do we explain subjective experience and self-awareness? The simulation hypothesis is one of the greatest open questions in science. While it remains speculative, it pushes the boundaries of how we think about reality, physics, and technology. If true, who or what created the simulation? If false, why does reality look so much like a computer program? For now, we may never know, unless, of course, the simulation decides to reveal itself. Would you take the red pill or the blue pill? Level 63. Could there be unknown quantum particles influencing human thought? Some researchers speculate that undetected quantum forces might subtly impact neural activity, decision-making, or even consciousness itself. While mainstream neuroscience relies on classical physics to explain brain function, quantum mechanics introduces strange phenomena like entanglement and superposition that could play a hidden role in cognition. Quantum effects are already known to influence biological processes such as photosynthesis and bird navigation. So, could something similar be happening in the brain? If so, could this help explain intuition, gut feelings, or other unexplained cognitive phenomena? The possibility that human thought is influenced by quantum-scale interactions remains a deep and speculative mystery. Level 64. In 1976, NASA's Viking 1 lander ran a test to detect life on Mars. It mixed Martian soil with a nutrient solution containing radioactive carbon. The result? A strong release of gas, just like microbial metabolism on Earth. At first, it seemed like we had found alien life. But then, another test searching for organic molecules found nothing. NASA concluded the reaction was due to unusual Martian chemistry, not life. Decades later, we learned that Mars's soil contains perchlorates, which could have destroyed any organics Viking was looking for. Some scientists now argue Viking 1 may have actually detected life, but we dismissed it too soon. Did we unknowingly discover aliens nearly 50 years ago? The mystery remains. Level 65. The WOW signal is one of the greatest unsolved mysteries in the search for extraterrestrial intelligence. Detected on August 15, 1977, by the Big Ear radio telescope at Ohio State University, this strange radio transmission lasted for 72 seconds and originated from the Sagittarius constellation. The signal was so unusual that astronomer Jerry Amon, who was analyzing the data, circled it on the printout and wrote "WOW" next to it, hence the name. What made the WOW signal extraordinary was its intensity and narrow bandwidth, which resembled the kind of signal that might be deliberately sent by an intelligent civilization. It was detected at a frequency of 1,420 megahertz, the exact frequency emitted naturally by hydrogen, the most abundant element in the universe. Many scientists believe that if extraterrestrials were to send a signal, they might choose this frequency because of its universal significance. Despite extensive follow-up efforts, the WOW signal was never detected again. Scientists have searched the same region of space multiple times, using more advanced equipment, but have found nothing. Some have proposed natural explanations, such as comets emitting radio waves, but these theories remain controversial. The lack of repetition or any clear source means that, to this day, no one knows what caused it. The mystery of the WOW signal continues to spark debate. Was it a transmission from an intelligent civilization, a bizarre cosmic coincidence, or just an unknown natural phenomenon? Until we detect another signal like it, the answer remains one of science's most intriguing open questions. Level 66. For centuries, we've asked one of the biggest questions. What is reality? At first, it seems simple. Reality was made of matter, tiny particles that formed everything we see. But as physics advanced, something unexpected was discovered. The deeper we looked, the more it seemed that reality wasn't made of particles at all, but of something much stranger. At the heart of modern physics lies quantum field theory. It tells us that every particle, every force, and every interaction is not just a thing, but a ripple in an underlying field. The electron, not a tiny speck of matter, but an excitation in the electron field. Light, not just a particle called a photon, but a disturbance in the electromagnetic field. According to this view, the universe isn't a collection of objects. It's an intricate dance of invisible fields, shaping everything around us. But if reality is made of fields, a deeper mystery emerges. Fields are not tangible things. We cannot hold them, see them, or even measure them directly. They are abstract mathematical constructs that exist in space, vibrating, interacting, and giving rise to everything we perceive. So, if everything we experience is just the result of disturbances in these invisible fields, does that mean reality itself is nothing but an illusion? And then there's the weirdest part. Quantum fields don't just sit there waiting to be measured. In quantum mechanics, observation plays a fundamental role in determining reality. A quantum particle exists in a superposition of possibilities until we look at it. The moment we measure it, the wave function collapses, and a single outcome emerges. But before that, the system exists in a state of pure probability. Some interpretations suggest that quantum fields do not create reality on their own. Only when an observer interacts with them does something definite emerge. In other words, the very act of looking might be what brings the universe into being. This idea, unsettling as it is, has led to some of the most radical interpretations of physics. Could consciousness itself be responsible for collapsing the wave function, turning potential into reality? If so, does that mean reality doesn't exist without an observer? Or is reality already there, independent of measurement, just waiting for us to understand it? Quantum field theory has given us the most accurate predictions in all of science, leading to technologies like semiconductors, lasers, and even our understanding of the forces of nature. Yet, at its core, it remains deeply mysterious. Do quantum fields create reality? Or is there something even deeper hiding beneath them, waiting to be discovered? Level 67. Honeybees are incredibly intelligent for their tiny size. They can communicate, navigate vast distances, and even recognize human faces. But perhaps one of the most mind-blowing discoveries is that bees understand the concept of zero. That's right, one of the simplest yet most abstract mathematical ideas. Something humans didn't fully grasp until thousands of years after we started counting, is understood by these tiny insects with brains smaller than a grain of rice. So, how do we know this? Scientists conducted experiments where bees were trained to recognize quantities. The bees were shown sets of dots, and when they correctly identified the smallest number, they were rewarded with a sugary treat. Over time, researchers introduced an empty set, 0 dots. Incredibly, the bees treated the empty set as a numerical value and correctly placed it in order, recognizing that 0 was lower than 1. This might sound simple, but it's a major cognitive leap. 0 is an abstract concept. Most animals can distinguish between different numbers, but understanding that nothing is a number takes higher-order thinking. Before this experiment, only a few animals, like primates and some birds, had been known to grasp the idea of 0. The fact that bees with their minuscule brains can do this suggests that numerical understanding might not require a big brain at all. But why would bees need to understand 0? It could be useful for decision-making in their daily lives. If a flower has no nectar, it's better to avoid it rather than waste energy. Recognizing the absence of something as a meaningful piece of information might help bees optimize their foraging and survival strategies. This discovery raises even bigger questions. If honeybees, with such limited neural hardware, can grasp 0, does that mean the ability to understand complex concepts is more about neural efficiency than raw brain size? Could it mean that intelligence, or at least numerical reasoning, evolved independently in different branches of the animal kingdom? And here's something even weirder. The way bees process zero is surprisingly similar to how young human children and even some primates do. They struggle slightly when distinguishing between 0 and 1, but can easily differentiate between larger numbers. This suggests that the way our brains and bee brains handle numerical concepts might be more alike than we ever imagined. The more we study honeybees, the more they surprise us. Their tiny brains seem to pack an extraordinary amount of cognitive power, challenging what we think we know about intelligence. If an insect can grasp something as abstract as 0, what else might nature have figured out long before we did? Level 68. Tachyons. The hypothetical particles that could travel faster than light. If they exist, they would violate some of the most fundamental principles of physics as we know them. But do they actually exist? Or are they just a mathematical quirk, an idea that looks interesting on paper but has no place in reality? To understand tachyons, we need to go back to Einstein's theory of relativity. According to relativity, nothing with mass can reach or exceed the speed of light. The closer an object gets to light speed, the more energy it takes to keep accelerating it, and at light speed itself, it would take infinite energy. But tachyons, if they exist, wouldn't start from rest and speed up like normal particles. Instead, they would always travel faster than light. Here's the strange part. While normal particles gain mass as they approach light speed, tachyons would gain mass as they slow down. In other words, they would never be able to slow down to the speed of light, just as we can never speed up to it. This makes them behave in ways that seem bizarre, even paradoxical. If tachyons were real, they could, in theory, send signals into the past, violating causality. This means an effect could happen before its cause, breaking our normal understanding of time. Tachyons first emerged in theoretical physics through equations rather than observations. In 1967, physicist Gerald Feinberg coined the term when he explored the mathematical possibility of particles that always move faster than light. The equations work. There's nothing that outright forbids them in the math. However, in the real world, no experiment has ever detected a tachyon. If they did exist, they might constantly be converting into other particles, making them impossible to detect directly. Some physicists have suggested that tachyons could be a sign of an unstable system rather than a real physical particle. In quantum field theory, if a system predicts tachyons, it often means the theory needs to be rewritten to remove them, much like how imaginary numbers appear in equations, but don't represent physical quantities in most cases. Still, the idea hasn't been completely dismissed. Some versions of string theory include tachyons, and scientists have speculated that they might play a role in the early universe. There have even been claims of experiments detecting tachyon-like effects in cosmic rays, but none have been confirmed. So, are tachyons real? Right now, they remain purely theoretical. They're allowed by certain mathematical frameworks, but there's no solid evidence that they actually exist. If they do, they could rewrite our understanding of time and causality. But until we find them, they remain one of the many fascinating mysteries at the edge of physics, an idea that might just be too strange for reality to allow. Level 69. What is the true shape of the universe? It might seem like a simple question, but the answer is anything but. The universe isn't something we can step outside of and observe. It's a vast, possibly infinite expanse shaped by the laws of physics. According to Einstein's theory of general relativity, space itself bends and stretches based on the mass and energy within it. This means the universe could have one of three possible shapes: flat, spherical, or saddle-shaped. If it's flat, traveling in a straight line would continue forever. If it's spherical, space would curve back on itself, meaning you could eventually return to your starting point. If it's saddle-shaped, space would warp outward in strange ways. Measurements of cosmic background radiation suggest the universe is extremely close to flat, but that doesn't rule out curvature on a scale too vast for us to detect. Some theories even suggest the universe could be shaped like a donut, looping in ways beyond human intuition. And then there's the possibility that the universe has no shape at all. Perhaps space extends infinitely, or it could be part of a higher dimensional structure we can't comprehend. We may never truly know, but as our understanding of physics deepens, we inch closer to unlocking the ultimate shape of reality itself. Level 70. Cosmic filaments are among the largest structures in the universe, forming vast, web-like patterns that stretch across billions of light years. These filaments are composed of galaxies, dark matter, and hot gas, creating an intricate network that connects galaxy clusters like the threads of a cosmic spider web. But why do these filaments exist? What fundamental forces and principles shape the universe into this grand design? The answer lies in the early moments after the Big Bang. When the universe was young, it was nearly uniform, with only tiny variations in density. However, gravity caused these small fluctuations to grow over time. Areas with slightly more mass pulled in surrounding matter, creating dense regions that would later form galaxies and galaxy clusters. Meanwhile, the less dense areas emptied out, forming cosmic voids. This process, driven by gravity and dark matter, shaped the universe into a vast web-like structure. Dark matter plays a crucial role in this formation. Although invisible, dark matter's gravitational influence helps guide the movement of ordinary matter, pulling it into filaments over billions of years. Simulations of the universe's evolution show that as galaxies and gas flow along these filaments, they funnel into massive nodes, regions where galaxy clusters form. The filaments act as bridges, channeling matter from one part of the universe to another. The filaments themselves are immense, sometimes stretching hundreds of millions of light years. Despite their vastness, they are surprisingly thin compared to the dense galaxy clusters at their intersections. They also contain a significant portion of the universe's missing matter. Scientists estimate that much of the unaccounted for ordinary matter exists as diffuse gas within these filaments, making them crucial to understanding the total composition of the cosmos. Observing cosmic filaments is challenging. Unlike galaxies, which shine brightly, filaments are mostly composed of faint gas and dark matter. However, astronomers have detected them by observing how light from distant galaxies interacts with the gas inside them. Some filaments have even been seen through weak gravitational lensing, where their mass slightly bends the light from background objects. One of the biggest unanswered questions is whether cosmic filaments influence the evolution of galaxies. Some theories suggest that filaments act as highways, directing galaxies and intergalactic gas along specific paths. This motion might determine how galaxies form, merge, and grow over time. Some evidence suggests that galaxies born within filaments have different properties than those in isolated regions. Cosmic filaments challenge our understanding of large-scale structure formation and the interplay between dark matter, gravity, and ordinary matter. While simulations provide clues, the exact mechanisms governing their formation and influence remain open questions in cosmology. As telescopes become more advanced, scientists hope to unravel more details about these enigmatic structures, shedding light on the cosmic web that shapes the universe. Level 71. Time travel. It's one of the most fascinating concepts in science and fiction alike. But is it actually possible? Scientists have debated this question for decades, and while we haven't built a working time machine yet, physics suggests that time travel might not be entirely impossible. First, let's start with Einstein's theory of relativity. According to special relativity, time slows down the faster you move. If you were to travel close to the speed of light, time would pass much more slowly for you compared to someone who stayed on Earth. This is called time dilation, and it has been experimentally confirmed using high-speed particles and atomic clocks on airplanes. So, in a way, we already know that time travel into the future is possible, just not in a way that's useful for humans. But what about traveling to the past? That's where things get tricky. Einstein's general theory of relativity suggests that massive objects bend space-time, and in extreme cases, they might create closed time-like curves, a theoretical way to loop back in time. Some physicists have proposed that rotating black holes or wormholes might allow for backward time travel. A wormhole, if it existed, could theoretically connect 2 points in space-time, allowing someone to jump between different times. However, no evidence of naturally occurring wormholes has been found, and even if they did exist, keeping them stable would require something called exotic matter, a form of matter with negative energy that we don't yet know how to create in large amounts. There's also the issue of paradoxes. The most famous one is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born, meaning you couldn't have traveled back in time in the first place. Some theories try to resolve this paradox, like the many worlds interpretation of quantum mechanics, which suggests that every time travel event would create an alternate timeline rather than changing the past in our own universe. Then there's the Novikov self-consistency principle, which suggests that if time travel is possible, events must align in a way that prevents paradoxes, meaning no matter what you do in the past, the timeline would correct itself to ensure consistency. For example, if you tried to stop a historical event from happening, something else would intervene to ensure it still takes place. So, where does that leave us? While time travel into the future is technically possible under extreme conditions, traveling to the past remains deeply uncertain. The laws of physics don't outright forbid it, but we would need new breakthroughs in quantum mechanics, exotic matter, or wormhole physics to make it work. Until then, time travel remains one of the greatest scientific mysteries, one that may take centuries, or perhaps even an entirely new understanding of physics, to unravel. Would you take a trip to the past or future if you had the chance? Let's keep the discussion going in the comments. Level 72. Phantom DNA is one of the strangest and most controversial mysteries in modern science. The idea comes from experiments conducted in the 1980s and 1990s by Russian scientist Vladimir Poponin, who claimed to have discovered a phenomenon where DNA appears to leave behind an imprint in empty space, even after the physical DNA itself is removed. The experiment involved placing DNA molecules inside a vacuum chamber and shining a laser through them to observe how the light scattered. As expected, the DNA caused predictable changes in the light pattern, but the truly bizarre part came when the DNA was removed. Instead of the light scattering pattern returning to normal, the pattern that had been influenced by the DNA remained as if the DNA was still there. This effect, which Poponin called the DNA phantom effect, suggested that somehow the space where the DNA had been retained a memory of its presence. This discovery raised deep questions about the nature of reality. How could something that was no longer physically present still influence the environment? Was this evidence of a new physical phenomenon, or was it some unknown property of quantum fields? Some have speculated that this could relate to the way information is stored in the fabric of space, a concept that echoes ideas in quantum mechanics and holographic universe theories. Despite its fascinating implications, phantom DNA has remained on the fringes of science. The effect has not been widely replicated by mainstream scientists, and many believe that the results could be due to experimental errors or misinterpretations. Critics argue that, without independent confirmation, the findings remain speculative at best. However, if the effect were real, it could force us to rethink fundamental ideas about biology, quantum physics, and even consciousness. At its core, the mystery of phantom DNA touches on one of the biggest questions in science. Is reality shaped only by physical matter? Or is there an invisible structure to space itself that can hold information? If such an imprint is possible, it could hint at mechanisms beyond our current understanding, potentially linking biology to deeper physical laws we have yet to discover. Whether phantom DNA turns out to be a groundbreaking discovery or an illusion, it remains one of the strangest unsolved mysteries in science. Level 73. Interstellar objects like Oumuamua are among the most intriguing mysteries in modern astronomy. Unlike comets or asteroids from our solar system, these objects originate from deep space, beyond the influence of our sun. Oumuamua, discovered in 2017, was the first confirmed interstellar object to pass through our solar system, and its strange behavior left scientists puzzled. The biggest question is how such an object could form and why it appeared so different from typical comets or asteroids. Most known space rocks follow predictable patterns. Asteroids are dense, rocky bodies, while comets contain ice that sublimates into a tail when they approach the sun. However, Oumuamua didn't behave like either. It had no visible comet-like tail, even as it sped past the sun, and its shape appeared unusually elongated, more like a cigar or a thin pancake than a typical space rock. One possibility is that Oumuamua was a fragment from the violent breakup of a planetesimal, a small planetary body that formed early in another star system. During its journey through space, tidal forces from a larger planet or star could have stretched it into its unusual shape before slingshotting it out of its home system. Some researchers suggest it might be a shard of frozen nitrogen, similar to Pluto's surface, which could explain why it appeared comet-like but lacked a visible tail. Another hypothesis is that it could have been a hydrogen iceberg, a rare form of icy body that sublimates pure hydrogen, which would be invisible to our telescopes. This would explain why Oumuamua seemed to accelerate slightly as it left the solar system, an effect usually seen in comets but without the visible outgassing. Perhaps the most controversial idea is that Oumuamua was an artificial construct, possibly a derelict probe or light sail from an alien civilization. This idea gained traction due to the object's unexplained acceleration and its unusual shape, which some scientists argued could be consistent with a thin, reflective sail pushed by starlight. While most astronomers reject this explanation in favor of natural processes, the fact remains that Oumuamua did not fit neatly into any known category of space objects. Unlike typical asteroids and comets, Oumuamua was already moving at an extremely high velocity when it entered our solar system, meaning it could not have originated from within. Its speed and trajectory indicated that it was simply passing through, with no chance of returning. This suggests that interstellar objects may be more common than we previously thought, drifting through the void after being ejected from their home systems. One challenge in solving the mystery of Oumuamua is that it was only visible for a short period. By the time astronomers realized how unusual it was, it had already passed closest to the sun and was rapidly fading from view. Without a chance to send a probe or gather more detailed observations, its true nature remains uncertain. With future telescopes like the Vera C. Rubin Observatory expected to detect more interstellar objects, scientists hope to learn more about how these mysterious travelers form and what they can tell us about planetary systems beyond our own. Whether Oumuamua was a fragment of a destroyed world, a strange hydrogen iceberg, or something else entirely, it has opened a new chapter in the study of objects from beyond our solar system. Level 74. What is the most fundamental particle? At the heart of physics lies the quest to find the most fundamental building blocks of reality. Scientists have long sought the smallest indivisible pieces of the universe, the ultimate constituents of matter and energy. But as we probe deeper into the fabric of existence, the answer becomes more elusive. For centuries, atoms were thought to be the smallest units of matter, but the discovery of protons, neutrons, and electrons in the early 20th century shattered that notion. Then physicists found that even protons and neutrons were made up of quarks, held together by the strong nuclear force. Electrons, on the other hand, appeared to have no internal structure, making them prime candidates for being fundamental. The standard model of particle physics, the best framework we have for understanding the subatomic world, proposes a set of fundamental particles, quarks, leptons, which include electrons, and force carriers like photons and gluons. According to this model, quarks and leptons are indivisible. They have no known substructure. However, some theories suggest that quarks and electrons might not be fundamental after all. String theory, for example, proposes that all particles are actually tiny vibrating strings of energy, with different vibrational modes giving rise to different particles. If string theory is correct, then the most fundamental entity isn't a particle at all, but a one-dimensional string. To complicate matters further, physicists have long sought a deeper unification of forces and particles. Some have proposed that particles might emerge from even more fundamental entities, perhaps energy fluctuations in a deeper quantum field, or structures within higher dimensional space. The idea that space and time themselves could be made of something more fundamental is gaining traction in theoretical physics. So, what is the most fundamental particle? As of today, quarks and electrons are the best candidates. They have no known size or structure and are treated as point-like in our best theories. But history shows that every time we think we've reached the bottom, nature surprises us with another layer. The search for the true foundation of reality continues. Level 75. Does the soul exist? This question has fascinated philosophers, scientists, and theologians for millennia. But what does science actually say about the soul? Most religious traditions describe the soul as an immortal, non-physical essence that exists independently of the body. It is often thought to be the source of consciousness, personality, and identity. However, from a scientific perspective, things get much more complicated. the field of neuroscience tells us that everything we experience, our thoughts, emotions, memories, and even our sense of self, arises from brain activity. When neurons fire in certain patterns, we feel love, pain, curiosity, or fear. When the brain is damaged, a person's personality or memories can change. If consciousness and identity are so closely tied to the physical brain, then what room is left for an independent soul? But some argue that science hasn't explained everything. Certain near-death experiences describe people reporting vivid encounters with an afterlife or seeing things they shouldn't be able to see while clinically unconscious. Though skeptics attribute these experiences to brain chemistry, others suggest they hint at something beyond material existence. Quantum physics adds another layer of mystery. Some researchers speculate that consciousness might have roots in the fundamental structure of reality itself. Theories like quantum consciousness propose that our minds could be linked to quantum processes that extend beyond the body. Could this be a scientific foundation for what we call the soul? Despite centuries of debate, there is no definitive proof one way or the other. The question of whether the soul exists remains one of science's greatest mysteries, one that may never have a concrete answer. But as our understanding of consciousness deepens, we may one day find that the answer is far stranger than anyone ever imagined. Level 76. The Great Attractor is a mysterious gravitational anomaly pulling entire galaxy clusters, including the Milky Way, toward it at over 600 kilometers per second. But what is it, and why can't we see it? It lies about 150 to 250 million light-years away, in the zone of avoidance, a region obscured by the dense stars and dust of our galaxy. This makes it invisible to optical telescopes, but radio and X-ray observations reveal a massive concentration of galaxies, including the Norma cluster, exerting an immense pull. However, the Great Attractor might not be the final destination. Beyond it lies the Shapley supercluster, an even more massive structure pulling us in. Whether it's a dense region of galaxies, dark matter, or something new in physics, the true nature of the Great Attractor remains one of the biggest cosmic mysteries. Level 77. Imagine looking up at the night sky and realizing our universe might be just one of many. What if beyond what we can see, countless other universes exist, each with their own stars, galaxies, and even different laws of physics? One reason scientists consider this is cosmic inflation, the theory that the universe expanded rapidly after the Big Bang. Some versions suggest that different regions of spacetime formed bubble universes, each separate from our own. Then there's the quantum multiverse, where every quantum event creates a new universe. In this view, there's a universe where you made a different decision this morning, another where dinosaurs still roam, and countless more. String theory adds another possibility. Higher dimensions where other universes exist parallel to ours, invisible but just as real. And some even speculate we could be in a simulation, with many more simulated universes running alongside ours. So, how many universes exist? The truth is, we don't know. It could be just one, ours, or infinite, beyond anything we can measure. If the multiverse is real, then somewhere, another version of you is watching this video, asking the very same question. Level 78. Throughout history, humans have dreamed of immortality, but can science make it a reality? One approach is biological immortality, stopping or reversing aging. Some creatures, like the jellyfish Turritopsis dohrnii, can regenerate indefinitely. Scientists are exploring telomere extension and genetic modification to slow aging, but ethical and biological challenges remain. Regenerative medicine offers another path. Stem cell therapies and lab-grown organs could replace damaged tissues, potentially extending life indefinitely. Meanwhile, some futurists suggest mind uploading, transferring consciousness to a digital medium. Though far from reality, rapid progress in brain-computer interfaces makes it an intriguing possibility. Even if we achieve immortality, should we? An endless life could bring challenges like boredom, overpopulation, or new ethical dilemmas. While science is making progress, true immortality remains one of humanity's greatest mysteries. Level 79. Intelligence has shaped the world as we know it, but what will ultimately happen to it? Will intelligence continue evolving, or will it reach an inevitable end? If intelligence continues to advance, it could spread beyond Earth, adapting to new environments and even merging with technology. Some scientists speculate that artificial intelligence may surpass human intelligence, leading to a new era where biological and machine intelligence merge. This could create a form of consciousness that no longer relies on physical bodies, existing purely as data or energy, able to explore the universe indefinitely. But intelligence may also have limits. Civilizations could destroy themselves before reaching an advanced state, whether through war, environmental collapse, or uncontrolled AI. Even if intelligence survives, the universe itself is not eternal. If the universe expands forever and experiences heat death, all energy will eventually be lost, making any form of intelligence impossible. Another possibility is that intelligence finds a way to escape the boundaries of this universe, altering its own nature or even creating new realities. Some theories suggest intelligence could play a role in shaping the future of the cosmos, becoming something beyond our current understanding. For now, the ultimate fate of intelligence remains unknown. Whether it thrives, evolves into something unimaginable, or fades away entirely, is one of the deepest mysteries we may ever face. Level 80. Our entire experience of reality is shaped by three spatial dimensions: length, width, and height. But why do we perceive the world this way? And could there be more dimensions beyond our perception? One reason is biological. Our eyes and brain work together to interpret depth, using cues like perspective, motion, and stereoscopic vision from having two eyes. This gives us a three-dimensional understanding of space, allowing us to navigate the world effectively. Evolution likely favored organisms that could perceive depth, as it helped with survival, hunting, avoiding predators, and understanding distances. Physics also suggests that three dimensions might be fundamental to the way the universe works. In three-dimensional space, gravity and electromagnetic forces function in ways that allow stable planetary orbits, the formation of complex structures, and the emergence of life. If we lived in two dimensions, physics as we know it wouldn't work the same way. But what if there are more than three dimensions? String theory proposes that extra dimensions exist, but they are curled up at microscopic scales, too small for us to perceive. Some physicists believe that higher dimensional spaces could explain mysteries like dark matter or the true nature of gravity. Our perception of three dimensions might just be a limitation of human senses. If higher dimensions do exist, we may never experience them directly, but their effects could shape the universe in ways we have yet to understand. Level 81. Quantum gravity is one of the biggest unsolved mysteries in physics. Our current understanding of reality is built on two pillars: general relativity, which explains gravity on a large scale, and quantum mechanics, which governs the smallest particles. But these two theories don't fit together. General relativity describes gravity as the bending of space-time, while quantum mechanics suggests that everything, including gravity, should be made up of tiny discrete units. The problem? No one knows what those fundamental units of gravity are or how they behave. Many physicists believe that space and time themselves might be quantized, meaning they come in tiny, indivisible chunks at an unimaginably small scale called the Planck length. Some theories suggest that gravity is carried by a hypothetical quantum particle called the graviton, but no experiment has ever detected one. String theory proposes that all particles, including gravitons, are tiny vibrating strings rather than points, but direct evidence for this is lacking. Another approach, loop quantum gravity, suggests that space-time is woven from tiny loops, giving it a discrete structure rather than being smooth and continuous. Despite these ideas, no theory of quantum gravity has been proven. One challenge is that gravity is incredibly weak compared to other forces, making its quantum effects nearly impossible to detect. Another issue is that black holes seem to break all our current rules. Where quantum mechanics says information must always be preserved, black holes appear to erase it completely, leading to what's known as the black hole information paradox. If we could crack the mystery of quantum gravity, it could unlock an entirely new understanding of the universe, perhaps even revealing what happens inside black holes or what existed before the Big Bang. But for now, the true nature of gravity at the quantum level remains one of the greatest mysteries in physics. Level 82. Why does anything exist at all? This is one of the deepest mysteries in science and philosophy. If nothing had ever existed, no universe, no space, no time, there would be no one to question it. But instead, here we are, living in a vast, complex cosmos. Why? Some physicists suggest that nothingness might be unstable. In quantum mechanics, empty space isn't truly empty. It seethes with virtual particles popping in and out of existence. If the universe emerged from a quantum fluctuation, it could mean that nothing was never truly possible in the first place. Another theory is that the laws of physics require something to exist. Some equations suggest that a total balance of positive and negative energy could result in a universe where the net energy is zero, meaning something could arise without violating fundamental laws. Others speculate that the universe exists simply because it had to. Certain interpretations of physics suggest that, given infinite possibilities, a universe like ours would inevitably form. Some even argue that all possible universes exist in a vast multiverse, and we just happen to be in one where things turned out this way. But even if physics explains how the universe came to be, it doesn't necessarily answer why. The question of existence may go beyond science, touching on the limits of human understanding. For now, why there is something instead of nothing remains one of the most profound mysteries of all time. Level 83. Black holes are some of the most mysterious objects in the universe, places where gravity is so strong that nothing, not even light, can escape. But deep inside, beyond the event horizon, lies something even stranger: a singularity. A singularity is a point of infinite density where the known laws of physics break down. If we could see a singularity directly, it might reveal secrets about the nature of space, time, and even the fundamental structure of reality. This is where the cosmic censorship hypothesis comes in. Proposed by physicist Roger Penrose, it suggests that singularities must always be hidden behind event horizons, meaning the universe censors them from view. No naked singularities, points of infinite density exposed to the outside universe, should exist. If this hypothesis is correct, black holes act as cosmic safety nets, ensuring that the chaotic breakdown of physics remains hidden from the rest of the cosmos. But what if the hypothesis is wrong? Some theoretical models suggest that under certain conditions, a singularity could be exposed, violating cosmic censorship. If naked singularities exist, they could challenge our understanding of general relativity and might even provide clues to a deeper theory of quantum gravity. They could behave unpredictably, distorting time and space in ways we can't yet comprehend. So far, no naked singularities have been observed, but scientists continue to test the limits of this idea. If the cosmic censorship hypothesis holds true, the universe ensures that the deepest mysteries of physics remain hidden behind black hole event horizons. But if it doesn't, we may be on the verge of discovering an entirely new side of reality, one where the fundamental rules of the universe are laid bare for all to see. Level 84. In our everyday experience, objects exist in only one place at a time. A chair stays where it is, a person can't be in two locations at once. But in the strange world of quantum mechanics, particles don't follow the same rules. Electrons, photons, and other tiny particles can exist in multiple places at the same time, a phenomenon known as quantum superposition. This idea was famously demonstrated in the double-slit experiment, when a single particle, like an electron, is sent toward a barrier with two slits. It doesn't just go through one or the other. It behaves as if it passes through both simultaneously. The particle exists in a superposition of states, interfering with itself as though it were in two places at once. Only when it's observed does it choose a specific location, collapsing into a single outcome. But how does this actually work? One interpretation suggests that particles exist in multiple places until measurement forces them into a definite position. Another idea, the many worlds interpretation, proposes that every possible location actually exists in a separate branching reality. In this view, rather than the particle being in two places at once, the universe itself splits into different versions, each containing a particle in a different spot. Despite decades of experiments, the true nature of quantum superposition remains a mystery. Scientists are still trying to understand whether this strange behavior is a fundamental aspect of reality or just a limitation of how we observe the quantum world. If we ever unlock the full potential of quantum mechanics, it could revolutionize everything from computing to teleportation. For now, particles defy our everyday logic, challenging our very understanding of what it means to be in a single place. Level 85. For centuries, scientists have sought a single theory that explains everything in the universe, a grand unified theory. Right now, physics is built on two powerful but separate frameworks: general relativity, which describes gravity and the large-scale structure of the universe, and quantum mechanics, which governs the subatomic world. Both work incredibly well in their own domains, but they contradict each other at extreme scales, like inside black holes or at the moment of the Big Bang. A true grand unified theory would bridge this gap, unifying all the fundamental forces of nature into one equation. One of the main candidates is string theory, which proposes that everything in the universe is made of tiny vibrating strings, rather than point-like particles. This theory suggests extra dimensions beyond the familiar 3 of space and 1 of time, possibly solving the contradictions between relativity and quantum mechanics. Another approach is loop quantum gravity, which attempts to quantize space and time itself. Both ideas remain unproven, and testing them is difficult since they operate at energy scales far beyond our current technology. Physicists have already unified 3 of the 4 fundamental forces: electromagnetism, the weak nuclear force, and the strong nuclear force, into a single framework. However, gravity remains the outlier, resisting all attempts at unification. If a grand unified theory exists, it could answer some of the deepest questions in physics, like what happens inside black holes, what existed before the Big Bang, and whether the laws of the universe are truly fundamental or just emergent from a deeper reality. Despite decades of effort, no one has found the ultimate equation that explains everything. Some even wonder if such a theory exists at all, or if nature is simply too complex to be reduced to a single formula. Whether or not we ever discover it, the search for a grand unified theory continues to drive the quest for understanding the deepest mysteries of the cosmos. Level 86. Consciousness is one of the greatest mysteries in science, but could it actually shape reality itself? Some interpretations of quantum mechanics suggest that it might. In experiments like the double-slit experiment, particles behave differently when they are observed, as if the act of measurement changes their state. This has led some to question whether consciousness plays a fundamental role in shaping the physical world. Some physicists argue that this idea is a misunderstanding of quantum mechanics, that observation simply means interaction with a measuring device, not human awareness. But others believe there could be a deeper connection. Theoretical models like the participatory universe, proposed by physicist John Wheeler, suggest that consciousness and the act of observation may be essential to bringing reality into existence. Beyond physics, studies in psychology and neuroscience hint at consciousness influencing reality in more subtle ways. The placebo effect, for example, shows that belief alone can produce real biological changes in the body. If consciousness does have the power to shape reality, even in small ways, it could challenge everything we think we know about the universe. Could the mind have a role in shaping matter, time, or even the laws of physics? Or is consciousness just a passive observer in an indifferent universe? Science is still searching for answers, but the possibility that our awareness could be tied to the fundamental fabric of reality is one of the most intriguing mysteries of all. Level 87. We experience the world in 3 spatial dimensions: length, width, and height, plus time as the 4th dimension. But could there be more? Some theories in physics suggest that higher dimensions exist, even if we can't perceive them directly. One of the main ideas comes from string theory, which proposes that the fundamental building blocks of the universe aren't tiny particles, but vibrating strings of energy. For the math behind string theory to work, it requires extra dimensions, often 10 or 11 in total. These extra dimensions could be curled up so small that they are imperceptible to us, hidden within the fabric of space itself. Another reason physicists suspect higher dimensions might exist is gravity. Compared to other fundamental forces, gravity is extremely weak. Some theorists suggest this is because it leaks into higher dimensions, explaining why it appears so much weaker than electromagnetism or the nuclear forces. If higher dimensions exist, could we ever detect them? Scientists are looking for clues in particle physics experiments, such as those at the Large Hadron Collider, which could reveal evidence of extra dimensions through unusual particle interactions. Some also believe that cosmic phenomena like black holes or gravitational waves might offer hints about dimensions beyond the ones we know. If we could access these higher dimensions, it could revolutionize our understanding of reality. Some even speculate that advanced civilizations, if they exist, might already be using higher dimensions to travel or communicate in ways we can't yet comprehend. For now, the existence of higher dimensions remains an open mystery, but if they are real, they could hold the key to unlocking the deepest secrets of the universe. Level 88. Deep in the heart of quantum mechanics lies a strange and unsettling question. Does the universe need an observer to exist? The foundations of quantum theory suggest that particles do not have definite properties until they are measured. Before observation, they exist in a state of superposition, both here and there, both this and that, in a ghostly blur of possibilities. But the moment we look, the wave function collapses, and reality solidifies into one outcome. This raises an even deeper mystery. If observation is what defines reality, then what happens in the absence of an observer? Does the universe only exist because something, consciousness, measurement, or some unknown force, is constantly watching? The famous Schrödinger's cat thought experiment illustrates this dilemma. A cat in a box linked to a quantum event remains both alive and dead until observed. But who or what counts as an observer? Some physicists argue that consciousness itself plays a fundamental role in shaping reality, an idea that borders on philosophy. Others believe that observation is simply the result of interactions with the environment, a concept known as decoherence, where particles interact with their surroundings, making their states appear definite. But even this explanation leaves questions unanswered. If everything was once entangled at the beginning of the universe, does that mean reality only became real when the first observer, whoever or whatever that was, emerged? This mystery leads to bizarre possibilities. Could the universe itself be conscious in some way? Could reality be an illusion created by observation? Or is there some deeper hidden layer of physics that explains why things appear definite at all? Until we answer this, we may never truly know whether the universe exists independently, or only when someone is looking. Level 89. The human mind is one of the greatest mysteries in science, and some researchers believe that quantum mechanics might hold the key to understanding consciousness. This idea, known as the quantum mind hypothesis, suggests that consciousness arises not just from classical brain processes, but from quantum phenomena happening at a microscopic level inside neurons. One of the most well-known theories in this area comes from physicist Roger Penrose and anesthesiologist Stuart Hameroff. They propose that tiny structures inside brain cells, called microtubules, may act as quantum computers, processing information in ways that go beyond classical physics. If true, this could explain why human thought and decision-making feel so different from artificial intelligence or conventional computing. But there's a problem. Quantum effects are extremely delicate and usually require near-zero temperatures to be observed. The human brain is warm and full of chaotic biological activity, which should make quantum coherence impossible. Yet, some experiments hint that quantum processes might still play a role in biology, from photosynthesis to bird navigation, suggesting that life itself might harness quantum mechanics in unexpected ways. If consciousness does emerge from quantum processes, it could mean that the mind is more than just a biological machine. It might be tapping into deeper aspects of reality. Some even speculate that this could offer insights into free will, creativity, or even life after death. However, the quantum mind hypothesis remains highly controversial, with many neuroscientists arguing that classical physics is enough to explain consciousness. For now, the mystery remains. Whether the mind is purely a product of neurons or connected to the quantum world is one of the deepest unanswered questions in science. Level 90. What happens to consciousness after death is one of the deepest and most unsettling mysteries of existence. Science tells us that when the body dies, brain activity ceases, and with it, the conscious experience we associate with being alive. But does awareness simply vanish, or could it persist in some form beyond the body? Many neuroscientists argue that consciousness is purely a product of brain activity. When neurons stop firing, the self dissolves, much like a computer shutting down when it loses power. From this perspective, death is final, an irreversible state of nothingness. However, others believe that consciousness could be something more than just brain activity, possibly a fundamental aspect of the universe itself, woven into the fabric of reality in ways we don't yet understand. Near-death experiences have fueled the debate. Thousands of people who have been clinically dead for minutes or even hours have reported vivid experiences, floating above their bodies, seeing a tunnel of light, or encountering deceased loved ones. Some describe a profound sense of peace or an expanded awareness beyond space and time. While skeptics attribute these to oxygen deprivation, neurotransmitter surges, or hallucinations caused by a dying brain, others question whether these experiences suggest that consciousness can exist independently of the body. Quantum physics has also been pulled into the conversation. Some researchers propose that consciousness might not be a mere byproduct of brain function, but could have a quantum foundation. Theoretical physicist Roger Penrose and anesthesiologist Stuart Hameroff developed the orchestrated objective reduction theory, suggesting that consciousness arises from quantum processes inside microtubules within brain cells. If consciousness is tied to quantum states, some speculate it could persist in a different form after death, dispersing into the universe rather than ceasing to exist entirely. Religious and spiritual traditions have long offered answers, from the idea of reincarnation to eternal life in a spiritual realm. Some belief systems describe consciousness as an energy that continues its journey after death, whether as a reincarnated soul, a spirit in another dimension, or a force merging back into the cosmos. While these ideas provide comfort to many, they remain unproven by scientific standards. Ultimately, the fate of consciousness remains an open question, one that sits at the intersection of science, philosophy, and personal belief. While current research suggests that consciousness is dependent on the brain, there are still mysteries about the nature of awareness that science has yet to unravel. Whether consciousness is extinguished at death or continues in ways we cannot yet measure remains one of the greatest unsolved questions of human existence. Level 91. Some scientists and philosophers propose that reality isn't made of matter or energy at its core, but something even more fundamental: information. This idea suggests that everything we experience, from physical objects to consciousness itself, emerges from an underlying informational structure, much like data in a vast computational system. Could the universe be processing reality like a giant quantum computer? This idea is partly inspired by quantum mechanics, where particles don't seem to have definite properties until they are observed. Instead, they exist in multiple states simultaneously, governed by probabilities. Some interpretations suggest that reality doesn't truly exist in a physical sense until it is measured, as if the universe processes information when needed, similar to how a video game only renders what the player sees. Another compelling clue comes from black holes. Physicist Stephen Hawking discovered that black holes emit radiation and gradually shrink, leading to the paradox of what happens to the information about everything that fell inside. Modern theories suggest that, rather than disappearing, this information is somehow preserved on the event horizon, as if space itself is a kind of storage medium. This has led to ideas like the holographic principle, which proposes that our three-dimensional universe is actually encoded on a two-dimensional surface at the cosmic edge, making reality a kind of projection of pure information. Even physics equations hint at this idea. The laws governing the universe, from relativity to electromagnetism, can often be described in terms of information flow rather than traditional physical properties. Some researchers believe that space, time, and even mass itself might emerge from information interactions at the smallest possible scale, sometimes referred to as it from bit, a term coined by physicist John Wheeler, suggesting that reality arises from fundamental yes/no choices, like bits in a computer. If reality is ultimately information, what does that mean for consciousness? Some theories suggest that our own awareness could be part of this informational structure rather than something separate. This raises even stranger questions. Could reality itself be a kind of simulation? If information underlies everything, does that mean the universe was programmed in some way? Could our experience of reality be more like a process running on an unimaginably vast computational framework? While these ideas remain speculative, They challenge our deepest assumptions about what is real. If information is the true foundation of the universe, understanding it could redefine the nature of existence itself. Level 92. Nothingness seems simple, but the deeper you explore it, the stranger it becomes. In everyday life, we think of nothing as an empty space, a void where something used to be. But in physics, true nothingness doesn't seem to exist. Even in the vacuum of space, particles flicker in and out of existence due to quantum fluctuations. The fabric of reality itself is never truly empty. Philosophers have also struggled with this concept. If nothingness is the absence of everything, then it shouldn't exist at all. But if it doesn't exist, why is there something instead of nothing? Some argue that nothingness is just a human construct, a way to describe absence, not a state of reality. In cosmology, the nature of nothingness ties into the origins of the universe. Some theories suggest the universe emerged from a quantum vacuum, where spontaneous fluctuations created matter and energy. But if the laws of physics allowed this to happen, was it ever truly nothing to begin with? Even mathematically, defining nothingness is tricky. In set theory, the empty set is still something, a collection that contains no elements. Zero exists as a concept, but it's not the same as non-existence. So, does true nothingness exist? Or is it just an illusion, an impossible state that our universe never actually reaches? Science, philosophy, and mathematics all point to a strange conclusion. The very idea of nothing might be meaningless. Level 93. Physics has done an incredible job explaining the universe, from gravity to quantum mechanics. But could there be a fundamental law we haven't discovered yet? Every major scientific revolution has come from finding something unexpected. Newton's laws explained motion, but they couldn't account for extreme speeds or gravity's deeper nature, which Einstein's relativity later addressed. Quantum mechanics then revealed a bizarre, probabilistic world at the smallest scales, but it remains incompatible with relativity. Scientists have been searching for a unified theory that connects everything, but so far, no theory of everything has been confirmed. There are hints that something is missing. Dark matter and dark energy make up 95% of the universe, yet we don't know what they are. The anomalies in cosmic expansion, unexplained fluctuations in fundamental constants, and the mystery of why the universe seems finely tuned for life all suggest that our current understanding may be incomplete. Some physicists propose extra dimensions, hidden particles, or even a completely new force of nature. Experiments at the Large Hadron Collider and observations of deep space could provide the breakthrough. If we discover particles that don't fit the standard model, or find inconsistencies in the laws of gravity at extreme scales, it could point to an undiscovered law governing reality. Until then, the possibility remains one of the greatest mysteries in science. Level 94. The Big Bang Theory explains how the universe expanded from an incredibly dense and hot state, but it leaves one of the biggest mysteries unanswered. What came before it? One possibility is that time itself began with the Big Bang, meaning before has no meaning. In this view, space and time emerged together, and asking what came before is like asking what's north of the North Pole. Another idea is the cyclic universe, where the cosmos expands and contracts endlessly. Some theories suggest a previous universe collapsed in a big crunch, triggering a new Big Bang. This would mean our universe is just the latest in an infinite series. Quantum mechanics also offers strange possibilities. The universe may have emerged from a quantum fluctuation in a timeless vacuum. In this view, tiny quantum instabilities could have caused space-time to form spontaneously. Another theory is the multiverse, where our Big Bang was just one event in an eternal landscape of universes. Some physicists propose that new universes constantly bud off from others, meaning our universe might be just a small piece of a much larger reality. Despite these ideas, the truth remains unknown. The laws of physics break down at the singularity, making it impossible to probe directly. Until we develop a theory of quantum gravity, the question of what came before the Big Bang remains one of the greatest mysteries in science. Level 95. For centuries, philosophers and scientists have asked, what is reality truly made of? At first it seems simple, matter and energy forming the physical universe. But as we've probed deeper, reality becomes stranger. At the smallest scale, Everything is made of subatomic particles, but quantum mechanics suggests these particles don't have definite states until observed. Some theories suggest reality is not made of matter at all, but information, a vast computational process where particles emerge from mathematical laws. Space and time themselves might not be fundamental. Some physicists propose that space is an emergent property, built from entanglement between quantum bits. If true, reality is not solid, but a shifting web of probabilities. Others speculate we live in a holographic universe, where everything we experience is a lower dimensional projection of a deeper reality. Then there's the question of consciousness. Is it simply an illusion created by the brain, or could it be fundamental to reality itself? Some theories suggest the universe might be shaped by observation, meaning our minds play a more active role in shaping existence than we realize. Despite centuries of discovery, we still don't know the true nature of reality. Is it particles, waves, information, or something beyond human comprehension? The ultimate fabric of reality remains one of the deepest unsolved mysteries of science. Level 96. Some scientists and philosophers have proposed a mind-bending idea. What if the universe itself is conscious? This concept, known as panpsychism, suggests that consciousness isn't unique to humans, but is a fundamental part of reality, present even at the level of atoms and energy fields. One argument for this comes from the complexity of the human brain. If consciousness emerges from a network of neurons, could a vast cosmic network, such as galaxies, black holes, or quantum fields, also give rise to awareness on a much larger scale? Some physicists have explored whether the universe processes information in a way similar to a massive brain. Studies have even found structural similarities between the cosmic web of galaxies and the neural networks in the brain. Quantum mechanics adds another layer of mystery. The famous observer effect suggests that particles behave differently when measured, leading some to wonder whether consciousness plays a role in shaping reality itself. If so, does that mean the universe has some form of awareness? Others argue that this is just a misinterpretation of physics, and that consciousness is simply an emergent property of complex systems like the human mind. If the universe is conscious, what would that mean for us? Would it imply some grand cosmic purpose? Or is consciousness simply a fundamental part of existence, just like space and time? Science has yet to provide a clear answer, but the idea that the universe might be aware in some way remains one of the deepest mysteries of all. Level 97. Life on Earth has evolved for billions of years, adapting to extreme environments and taking on countless forms. But could an entirely new form of life emerge, something fundamentally different from anything we know? One possibility is the rise of synthetic life. Scientists have already created artificial cells and modified DNA beyond the standard four-letter genetic code. If we engineer organisms with entirely new biochemistries, they might evolve into life forms unlike anything seen in nature. Another scenario is extraterrestrial life. If life exists on other planets, it could be based on completely different chemistry, perhaps using silicon instead of carbon, or thriving in environments toxic to Earth-based organisms. If alien microbes arrived on Earth, could they adapt and evolve into something new? Even here on Earth, unknown life may already exist. Some scientists speculate about shadow biospheres, microscopic organisms with unique biochemistry that remain undetected. If such life exists, it would challenge our definition of what it means to be alive. Beyond biology, artificial intelligence is advancing rapidly. Could a self-aware AI, evolving through machine learning, be considered a new form of life? If machines develop autonomy, creativity, and self-preservation instincts, the line between life and technology might blur. If a new form of life emerges, how would we recognize it? Would it compete with us, coexist, or even surpass us? The future of life on Earth, or beyond, may be stranger than we can imagine. Level 98, absolute zero, negative 273.15 degrees Celsius or 0 Kelvin, is the coldest possible temperature, where all classical molecular motion is expected to stop. But what actually happens at this extreme limit? The laws of physics behave strangely as matter is pushed to the lowest possible energy state, revealing some of the most bizarre quantum effects ever observed. At absolute zero, classical physics suggests that all atomic motion should cease entirely. However, quantum mechanics tells us that even at this temperature, particles retain a tiny amount of movement due to zero-point energy. This means that atoms never truly stop vibrating, and uncertainty in their position and momentum remains due to Heisenberg's uncertainty principle. Scientists have been able to cool atoms to within billionths of a degree of absolute zero, unlocking exotic phases of matter. One of the most fascinating states observed near absolute zero is the Bose-Einstein condensate. In this state, individual atoms lose their identity and behave as a single quantum wave, essentially becoming one giant superatom. This bizarre form of matter allows particles to occupy the same quantum state, making them act in perfect unison. Other strange phenomena emerge at extreme cold. Superconductivity occurs in certain materials, meaning they lose all electrical resistance and allow current to flow indefinitely without energy loss. Similarly, superfluidity appears in liquid helium, where it flows with zero viscosity, climbing walls and moving through microscopic pores without friction. But is reaching absolute zero actually possible? According to the third law of thermodynamics, it isn't. The closer an object gets to absolute zero, the harder it becomes to remove the remaining heat. Cooling to absolute zero would require an infinite amount of work, making it physically unattainable. Despite this, by getting as close as possible, scientists are uncovering new insights into quantum mechanics, condensed matter physics, and even potential applications for quantum computing. Absolute zero remains an unreachable limit, but the discoveries made in its pursuit continue to push the boundaries of what we understand about the universe. Level 99. What if the universe is a growing organism? We think of the universe as a vast, cold expanse governed by physical laws. But what if it's something more, something alive? Some scientists have proposed that the universe might behave like a self-organizing system, similar to a living organism. It expands, evolves, and creates complex structures, much like a biological entity. Cells divide, replicate, and form larger structures. Galaxies, too, cluster together in patterns that resemble neural networks in the brain. The cosmic web, the large-scale structure of the universe, looks strikingly similar to the connections between neurons. Could this be more than coincidence? Could the universe itself be a form of intelligence, growing and adapting on a scale beyond human comprehension? If so, what is its purpose? Does it think? Is our consciousness a small fraction of its awareness, just as individual cells in our body have no sense of the whole organism they belong to? If the universe is alive, could it be reproducing? Some theories suggest black holes might seed new universes, acting like cosmic wombs. Could our universe be the offspring of another? If we are part of a living universe, it changes everything. We wouldn't just be observers of the cosmos, we'd be its neurons, part of a system far larger than we can imagine. But the biggest question remains. If the universe is alive, does it know that it is? Level 100. Scientists have long searched for a single theory that explains everything in the universe, a final theory of everything. Right now, physics is divided into two major frameworks: general relativity, which describes gravity and large-scale structures like galaxies, and quantum mechanics, which explains the behavior of particles at the smallest scales. The problem is, these two theories don't fully agree with each other. One major contender is string theory, which suggests that everything in the universe is made up of tiny vibrating strings rather than point-like particles. It attempts to unify all forces, including gravity, into a single mathematical framework. However, string theory remains unproven and has yet to make testable predictions. Another idea is loop quantum gravity, which tries to quantize space-time itself, potentially resolving conflicts between relativity and quantum mechanics. Some physicists believe the answer could lie in an undiscovered principle, something completely outside our current understanding. Others suggest that there may not be a single ultimate theory, that nature might be fundamentally unpredictable at some level. If a true theory of everything exists, it could revolutionize our understanding of the universe, unlocking deeper insights into space, time, and reality itself. But for now, the final answer remains one of the biggest mysteries in science.